Hey everyone, it's Andrew Brown, your favorite cloud instructor, bringing you another free cloud certification course, and this time it's the Google Cloud Gen AI Leader certification. So if you're looking to get certified in Google Gen AI, this is the course for you. We're going to do the usual thing that we do, which is doing lectures, hands-on labs, and I have a free practice exam for you, so you can ace that exam. If you like free courses like this one, the best way to support more courses is to purchase the additional study materials that will get you access to more practice exams, flashcards, cheat sheets, downloadable lecture slides, and more. And I've taught a lot here. So I've taught a lot of Google courses, AWS, Azure, Terraform, Kubernetes, and more. And basically all the AI courses in cloud, I'm the one who's teaching them. So you're in good hands here. But let's jump into the course and I'll see you soon, okay? All right, we're taking a look here at the Google Gen AI Leader. And so this certification is a concept-based Google Cloud certification teaching you fundamental Gen AI concepts, Google Cloud's Gen AI offering specifically for enterprise consideration, as that's what they want you to know. I need to point out that this is not a complete foundational course. There are other competitor courses like the AI 900 and whatever the one is called for AWS. And I would say that they go in greater depth in terms of Gen AI concepts. I have my own Gen AI Essentials course, which greatly covers that fundamentals. I would say that the amount of Gen AI concepts here is enough for who they're targeting for here, but I would just say that it is incomplete and you should just be aware of that. Google doesn't use course code, so we call this the GCP GAL based on the G, the A, and the L. So I'm calling the GCP GAL as we go through here. This is a very easy certification. In fact, it is the shortest and easiest Google Cloud certification. So if you're looking for an easy win, you don't mind paying the whatever it is, 99 USD, and you want to show that you have those skills, or just make sure you go through it, this is an easy one for you, folks. I would consider taking this if you are adopting Google Cloud Gen AI offering, if you're a key stakeholder, a solution architect, or a sales engineer, and you need to understand the Gen AI offering. But this is not a very much hands-on course. You can literally pass this with no hands-on experience, but I do make sure to show you things in the console just so that you can contextualize it for your own use cases, okay? I would recommend that you take the Cloud Digital Leader first because I'm going to jump right into the console, and my expectation is you do have some knowledge in GCP first. You could absolutely take this without taking the GCP Digital Leader first, but you might need to spend a little bit more time on it. Again, very, very easy course. I do need to remind folks that certifications do not validate programming, technical diagramming, code management, many other technical skills. So if you think that you're going to become a Gen AI engineer after this course, you're going to be far from it because there's not enough hands-on to do it. But for those in decision-making or need to know the offering, it'll be fine for that. How long to study? 5 hours if you're a beginner. Again, I recommend that GCP CDL there, and you can do it with no technical experience. If you are experienced, it's going to be a very easy course to complete, maybe 2 hours. I'd probably set this at 3 hours in the middle. I'm saying 40% lectures and labs and 60% practice exams. I rarely go this heavy. Usually I do this when we're talking about professional certifications, but because there's not a lot of lecture lab content, you do need to spend more time on the practice exams. Not that they're hard, but we'll talk about why in just a moment here. So watch those lectures and labs. I would say you can watch the labs. You don't have to do them. And in some cases, I will say, like, don't do this lab because I don't want you to run into spend, or we're just exploring it. So understand that follow-alongs are not that necessary for the certification. Do paid practice exams for this one. You absolutely want to do them. And it's not because the questions are hard, but they have tricky wording, okay? Because sometimes when exams are too easy, they end up using very generic language, like business language, and then it just kind of muddies what it is, what the answer is. And so we try to reflect that the best that we can. And so that's why I recommend that you do practice exams, okay? You can take this via Criterion through Web Accessor. That is the platform that Criterion uses for their online test centers. If you can do it in person, I strongly recommend doing so. They do use AI proctors these days. So a proctor is a supervisor, person who monitors the student during the examination. but they are leveraging AI to monitor you. So just be aware of that. It's becoming common now. They've probably been doing it for longer. At least Criterion tells us, other providers don't, but they definitely are using AI. In terms of the breakdown here, we have fundamentals of Gen AI, Google Cloud's Gen AI offering, improving the Gen AI model output, business strategies for successful Gen AI solutions. Each domain has its own weighting that determines how many questions in a domain that will show up. Passing grade 700, so 70% as per usual. If you get exactly 70%, you could fail. So make sure you aim above that. So when you do practice exams, I say go try to get 85%, because usually people are off by 10%, and so 75% gives you that buffer in terms of passing. There's 50 to 60 questions. I got exactly 50. I didn't get even 60 questions. You can get about 18 wrong here. There's no penalty. The format is multiple choice. I don't think it was multiple answer. I think it was just multiple choice. But anyway, if it is, it's not like it's going to be that hard. You only get 1.5 hours. So normally they give you 2 hours, but they only give you 1.5 on this. So I say about 2 minutes per question, but it's probably less than that. But again, you'll finish this very, very quickly. The exam time, 90 minutes, it's 1.5 hours. Buffer for 30 minutes, so you can review the instructions, show the online proctored your workspace, read and accept the NDA, complete the exam. Criterion I don't find very stressful. My laptop's broken right now, and I have a very strange setup, and they're very nice and accommodating, and despite my very strange-looking setup, so I was able to sit this exam no problem. I wouldn't stress out about it. Though I do find with Criterion that sometimes the phone check-in doesn't work for whatever reason. Their mobile web app is not very good, and so I just try to force it to do the desktop check-in. But yeah, the secure web accessor can be kind of a pain. So make sure that you show up early for this so that you can avoid that issue there. This is valid for 36 months, so 3 years. And there you go. So yeah, it should be an easy pass for you. Just make sure you use those practice exams to fill any gaps or tricky wording, and you'll be fine, okay? Ciao, ciao. Hey folks, it's Andrew Brown. Let's go through the official exam guide so I can give you some thoughts and opinions to prep you for this certification. I did sit this exam, of course, and actually I sat it blind and I passed. So that means I went in and I didn't study anything and I passed. And that's because I have knowledge from other providers. I'm already familiar with Google's offering. And I'm going to tell you, it was a really easy exam. Some of the wording was a bit tricky. It's just, again, because of the way they use business language and describe things. So some things could have been worded better, but for the most part, if you go through the materials, you should be able to pass, and definitely do the practice exams to deal with those tricky questions. So section 1 is fundamentals of Gen AI. I said earlier that I do feel that it's incomplete, but it's sufficient enough. So they want you to know AI, natural language processing, machine learning, Gen AI, foundational models, multimodal foundation models. They might have a question like, what is AI, right? And they might have a question like, what is NLP? But the rest here didn't really get a whole lot of questions. I packed in some of my foundational content from my Gen AI Essentials course. So, I could have made very specific content for that, but I don't feel that it was necessary. So I just brought that over, and that's front loaded into the course, just the materials that you need. So if you hear mention of other providers, that's why, because I brought that over. But anyway, we'll continue on here. So diffusion models, I don't think I covered that because there's no questions on the exam, but diffusion models is the type of models that we're utilizing. I do have this in the Gen AI Essentials, but it becomes very technical, and that was out of scope for that, so I didn't put it in here. Prompt tuning is knowing about the parameters, temperature, top P, things like that. Prompt engineering, we covered the types of prompt engineering in here that they will ask you. They will actually ask you, like, what is a one shot? What is a zero shot? Chain of thought. So we have lecture slides on that. Very simple stuff. Describing machine learning approaches. So you need to know supervised and supervised and reinforcement. So I have some slides on that for you. Identify the stages of machine learning. This didn't really come up on the exam. I do have like a generic one in the Google Cloud Digital Leader, which might have been brought over, but there was no questions about this. So I don't feel that this is necessary in terms of passing the exam, but you should know it because it's good to know. See, identifying how to choose the appropriate foundational model. There wasn't really any specific questions on this. It was more like if you had, I'm going to get my head a little bit out of the way because I know I'm covering some of the text here, but coming back to this one here, it was more like, oh, you're using Google Gemini, or like you need to use a multimodal thing, and you have to deploy it in your own local compute. So you can't use Google Gemini, but you can use Gemma, and so it would be as simple as that. So if you know generally what the models are, it's not going to be that hard to figure out what to use. Identifying business use cases for Gen AI, creating summary, discovery, text generation. So if you have a general idea of the functionality of Vertex Studio AI, you're going to know what to use. Describing how various data types are used in Gen AI. There wasn't really anything about data types, so there was nothing really to make on that, but we do cover data types in the course, so if there is something there, it'll get covered. Explain the characteristics and importance of data quality, data accessibility. No questions whatsoever on this, so I don't know why this is in here. Nothing whatsoever. I didn't get any. I sat it, and also my support engineer Peter sat this exam. We both didn't get it. I don't know why that is in the exam. Identifying the difference between structured and unstructured data, identifying real-world examples of each type. You don't really need real-world, but you do need to know the difference between structured and unstructured data. So that's pretty straightforward. Labeled and unlabeled data. If you know what labeled data is, it's data that's been manually labeled by a person. Then you know what unlabeled data is. It has no identification. Describe how various data types are used in Gen AI. So again, I mean, like, this just comes back to like structured and unstructured data and labeled and unlabeled data. So maybe that's what they mean by data types, but like data types generally means something even more specific, which wasn't really covered. So they must mean just unstructured and structured and labeled and unlabeled. And we covered that thoroughly in the course. Identify the core layers of the Gen AI landscape, infrastructure, models, platform, agents, applications. There was no questions whatsoever on this. So, and I mean, this is pretty straightforward. The infrastructure is what runs it. The models is what serves up the AI stuff. The platform is the comprehensive integrations of all their toolings. Agents is a model that acts like a human, and then you have your application on top of it. So there's really nothing to describe here in the course, but you can see the layers there. And if you had to identify them, I'm sure you'd figure it out. It's not too complicated. Identify the use case and strengths of Google's foundation models. So here they want you to know the difference between Gemini, Gemma, Imagen, and Video. I can tell you right now, Gemini, multimodal, it's fully managed, has different integrations or extra integrations with API. Gemma is just a model. It's open weights. You can download on your own machine. Some of them are not multimodal. The older ones aren't, but most of them are. Image is for generating images. Video is for generating videos. If you remember that, you'll get those pretty easily. But we do cover them, so you'll be sure to understand them. So let's take a look here. So we have Google Cloud's Gen AI offering. So describe Google's Gen AI first approach and commitment to future innovation. This is just like marketing nonsense. So if you get questions, you just have to best guess on the marketing questions, because there's nothing in particular that I can point to. Maybe within Google's official course, they might have some kind of text here, but I don't think you'll lose any points here, or you have to go seek out that other content. You'll just figure it out when you do the exam. Describe how Google Enterprise Ready AI platform is responsible, secure, private, reliable, scalable. I don't know, like they have, again, generic one-page marketing things, and you just kind of guess, and it's like the most obvious answer, and you'll get it. So that's totally fine. Recognizing the advanced Google's comprehensive AI ecosystem. I mean, this is no different than any other provider. So just think of like why it would be useful to have everything like it's. You don't even think of Gen AI. Just think of cloud, and you'll figure it out. Describes benefits of Google Cloud's open approach. I think I had one question about this, where it was like people were concerned about like vendor lock-in, and so you just had to choose the question that was the least concerning. So like if you were adopting it, just think of like what answer sounds the best to you for adoption, and you'll get that answer. But there's nothing like in particular, again, in the marketing pages about open approach. Maybe they just mean like Gemma has open weights and you have some options of other open models. But other than that, I don't really know what they're talking about. Identifying the essential components of Google Cloud AI infrastructure. So they might ask you questions about TPUs and GPUs, but I didn't get anything about hypercomputers. If you know what the TPU is, then you'll be fine. So we have a slide on that. I don't even think I updated it. There probably is a new TPU, but they're not going to ask you like what kind of TPU. It's a tensor processing unit. You just need to know that Google makes their own tensor processing unit specifically for machine learning, and GPUs can be used, but these are more efficient for working on tensors And they don't even talk about the TensorFlow framework, which is why you use tensors. So I'm surprised they don't have that in here, but that's fine. Explaining how Google Cloud AI Platform provides user controls over their data. Yeah, so there was questions about that kind of stuff, but that might be like about like service agents and things like that. If you've done the digital leader, you can just answer those. There isn't anything in particular that was specialized for it, so there's not much to say. Describing how Google AI's platform is democratized AI. Again, nonsense question. There's no real questions on that, or just guess your best for that. Describe how Google's pre-built GenAI offering enables AI-powered work. So recognizing the functionality, use case, business value of Gemini app and Gemini Advance. So we cover what gems are. Gems are just the same thing as ChatGPT's GPTs. It's just a template for if so you have to like fill it in every single time. And then like we look at Gemini. They say Gemini app, but I guess they just mean the generic Gemini application. I didn't get any questions actually about the Gemini app, but like if you know what ChatGPT is, there's the Gemini app. Like it's straightforward. They do have this thing called Agentspace, so that's what they're talking about, because Agentspace is like the Gemini app enterprise offering. And yeah, they mention it right here next, right? So that's probably what they're talking about. Cloud Notebook LM, so we look at that. They say API, but you really don't need to know the API. You just need to know what Notebook LM is. Multimodal search, custom agent capabilities. I think we cover those. Again, there's no questions on those. You just need to know what Notebook LM is and Google Agentspace. Recognizing functionality, use case, business values of Gemini for Google Workspace. This is just, you have Google Gemini within Google Workspace. That's it. That's all you need to know. And then it can work in your docs and your email and whatever programs they have, it will work in there. Describe how Google Cloud's GenAI offering improved customer experience. So again, it's just your best guess. Well, not necessarily here because it's talking about vector AI search and Google search. So if you know vector AI search is a out-of-the-box RAG and has specific integrations, you'll be good. And the fact that you can do grounding with Google search and with vector AI search, then that'll be straightforward as well. Here we have the customer engagement suite. I made sure to thoroughly cover this. I got a lot of questions on this. So, I made the videos for that and I do the labs for it. You don't have to do the labs, but again, I recommend watching them so you know fully how they work. Describe how Google empowers developers with AI. So the Vertex AI platform. So Model Garden, Vertex AI Search, AutoML. AutoML never came up once whatsoever in the exam. I don't even know why this is in here because I didn't get it. Peter didn't get it. I didn't make a slide on it, but I do cover it in the Google Digital Leader. AutoML just means it's like a machine learning model that is, it deploys all the stages for you and you can just choose some parameters, but it's in the Digital Leader, but I don't think we put it in this course and you're not going to get a question on it. And we wouldn't even know what to write a practice exam question on because we didn't see it. Model Garden is a model catalog. You'll see that so many times. It'll be very easy to understand what it is. Recognizing Google Cloud RAG offering. So here they're reinforcing about the Vertex AI search, about the built-in stuff for that. So that's pretty straightforward. Define the purpose and type. So identify how agents and tools interact with external environments to achieve their tasks. We could be talking about RAG here, or tool use or things like that. Identifying relevant Google Cloud services and pre-built AI agents for agent tooling. So agent tooling, again, is just calling out to things. And so they're just saying there's a variety of things that you have here. I didn't really get any questions like this, like Google Video Intelligence. I didn't get that. Document AI API, I didn't get that. Document, like none of this stuff. But this stuff is pretty straightforward. Like, they have text-to-speech API if you want to use it, right? It's pretty straightforward. And some of these things actually get covered in Vertex Studio AI. So Vertex Studio AI puts a layer on top of this stuff. But I guess here they're saying these are things you could specifically use for tool use. But again, there was no questions on a lot of these things here. So, but again, it's very straightforward what they are. Describing when to use Vertex AI Studio versus Google AI Studio. I couldn't tell you. I've used both of them. Google AI Studio is if you don't have a Google account, basically, like a Google Cloud account. So if you don't have a Google Cloud account, you probably want to use Google AI Studio. If you want more model access and more integration with Google Cloud, you're going to use Vertex AI Studio. That's it, right? If you use them, it's very straightforward, like what they can and can't do. Techniques to improve Gen AI models. So identify common limitations of foundational models like data dependency, knowledge cutoff, bias, fairness, hallucinations, edge cases. So I got questions for this, but I put these in the practice exams. So I don't think I made slides for this, but I definitely made practice exam questions for this. And so, if you had a question about data dependency, so again, I'm just going to tell you right now, make sure you do the free practice exam so you get the coverage for this one, because literally there'll be like 1, 2, 3, 4, 5, 6. You'll literally get 6 questions in your exam. And so if you can get these in the practice exams and experience that, you're absolutely going to get 6 points in your exam, no problem there. Describing the Google Cloud recommended practices to address limitations. I don't know where their best practices are. They're not in the docs. So whatever I did is what I would recommend. So whatever I do in the labs, that's going to be that. And again, remember, I passed this blind. So, if I can pass it blind, I think you'll be okay. Recognizing Google recommended practices for continuous monitoring, evaluation, generating models. So automatic upgrade models, key performance indicators. I think I had one question about KPI, security patch updates, versioning, performance, tracking, drifting, monitoring, Vertex AI feature store. A lot of these weren't on the exam, to be honest, but they have them here in the exam guide. Define prompt engineering, describing its significance in interacting with large language models. Identify prompting techniques and use zero-shot, one-shot, few-shot, role prompt chain. Definitely had a question for each of these. Okay, so I cover those in the lecture slides. I think I show you how to do those. And the practice exams at least have one of each of those. So that, again, is like 1, 2, 3, 4, 5 points. You see, like, if you do this, 5 points, 6 points, you're basically halfway there. You're getting there. Identify advanced prompting techniques when used. We do have React prompting, but they didn't have any questions. At least I didn't have. I did have a question on chain of thought prompting, so that's great. Describe the concept of grounding. So they're coming back to another section and repeating Vertex AI. And so grounding is basically going out and getting data from a RAG and making sure your data is up to date. And they're talking about RAG again and that stuff there. And they're talking about pre-built stuff. So literally they repeat this like 3-4 times. So you can see how this is a padded out exam guide. Then we talk about token count, temperature, top P, safety settings, output length. So I made sure to include a lecture slide on that. I always show it in the labs, but I went out of my way and made a lecture slide for that this time around. Describe the Google Cloud recommended steps to successfully implement a transform and Gen AI solution. So here we have text generation image. So this is just going through and knowing all the options of Vertex AI Studio. Again, this is just guessing what is the right thing. Describing how to use the right Gen AI solution. Again, this is just guess questions, so this is just fluff in here. Describe secure AI and the importance in protecting AI systems. So there is no questions on the SAIF. It's like a single page document and it's complete marketing nonsense. But I cover it. Same thing with this one as well. Secure by design gets mentioned. So if you see a question that says that it's an option for secure by design, just choose secure by design because, like, again, I couldn't find much information on it. So there was that. I remember I got a question on security command center. So if you know what that is, that's important. They're just talking about service accounts. So, whether you should grant service accounts or not to something. If we have a lack of this content in video form, they're definitely in the practice exams because I'm telling you, we wrote every possible practice exam question. And make sure you use the practice exams. I even tell you in the intro, 60% practice exam. So I'm just going to emphasize that over and over again. If there's something not in here, I felt that they should just be in the practice exams and you can just learn through that way. Explain the importance of responsible AI and transparency. I revisited the responsible AI page. Now, they used to, like, if you go to AWS and Azure, there's stuff that's more in detail, right? So I went responsible AI, Google. And there was just nothing here. They go here, you go, okay. It's like, all right, where is it? And you read about the principles, right? And they like bold innovation. That is not helping us here whatsoever. Like, what is that? So this is what I mean when I say there's a lot of marketing nonsense that is in here. But again, this is aimed at people for key stakeholders, sales engineers, and stuff like that. So maybe they want you to know that marketing stuff to carry forward to your customers, but I think it's a bit misaligned. And to be honest, you can just guess best for that and you'll be fine. Explain the importance of, no, we already read that. Describe privacy considerations, so risk, privacy, data normalization. So this stuff you'd want to know, usually use DLP for that, data loss protector. So DLP, GCP. So if you want to mask data or detect it or whatever, like obscure it, de-identify it, mask it, tokenize it, it's going to be DLP. Okay, so that's your answer right there, DLP. Okay. I don't know if you made a slide on that. Just DLP. Remember DLP. Describing the implications of data quality, bias, and fairness. Again, this stuff is more covered in the practice exams. I didn't make slides on those, and this is just a repeat of what was up here just a moment ago. But you want to know them all because you'll get 6 points. Okay. Describing the importance of accountability, explainability in AI systems. And so explainability. I don't think I made a slide on this either. Explainability AI. Google. We'll just take a quick look here. Because there's no, like when you use like Azure and AWS, they actually have very prescriptive tools that do explainable AI. Like they're literally specialized models. But for Google, it's just Vertex AI Explainable AI. And Vertex AI, Explainable AI just explains how the model works. Right. So if you get a question where there's, it's like a customer's it's an insurance company and, it's making biased claims against a minority group. And the company needs to prove that they're not being unfair. Explainable AI will explain how the model made its decisions. And that's all you need to know to answer that question. So yeah, there you go. I mean, again, it's not a hard exam. I'm just going to point out explainable AI, right? Security Command Center, that was another one there. DLP over here. And try to hit like, if we come back up here for a second, like know all these. They're in the practice exams. This is also as lecture slides. And the other one was these here. These are only in the practice exams. I don't think I made slides on this because it would be really boring to make. But anyway, there you go. And have fun and see you soon, okay? Ciao, ciao. Hey, this is Andrew Brown, and we are taking a look at the definition of what is artificial intelligence, and we really want to put this against the terms of machine learning, deep learning, and generative AI so that it's very clear what the differences are. Often people just say AI when they mean ML or deep learning, so understand that these terms are not used correctly often, but people generally will understand what you're trying to say, so it's not a big deal if you use them out of turn. But let's make sure that we know what they are. Let's first take a look here at artificial intelligence, also known as AI. These are machines that perform jobs that mimic human behavior. Okay, that's the key thing here, is that they are human-like or doing tasks that you'd expect a human to do. And that is clearly a very broad term of what is AI, and so you can see why a lot of things are attributed to being AI. Then you have machine learning. And machine learning, initialized as ML, is machines that get better at a task without explicit programming. Now, of course, we have to code a machine learning model, but once we have that model and we pass things into it, it's able to complete its task with its very complex algorithms. So you could also just think of it as it's a special algorithm to perform a task that would negate you having to do calculations or programming or things like that. Then we have what is deep learning. And when we think of a lot of the AI stuff, we're usually thinking of deep learning because it's these machines that have an artificial neural network inspired by the human brain to solve complex problems. So you probably have this, you've probably seen a graphic of it, of like these nodes and they're interconnected and they go through layers. That's deep learning. A lot of people call that machine learning or AI, but no, that's DL. Then we have Gen AI. So Gen AI, which is more of a marketing term, but generative AI is a specialized subset of AI that generates out content such as images, video, text, and audio. Now, I don't have it in the graphic on the left because it's hard to say where does it go. Does it go here, right? Because it is a subset of AI, but technically, Gen AI often utilizes deep learning because when we think of it, and my line's not drawing here today, but when we think of it, there we go, there's the line, is that a lot of Gen AI techniques like large language models or vision models and things like that are utilizing neural networks. So it is deep learning, okay? All right, so I know we keep talking about what is AI, what is Gen AI, but we're going to cover it again just so that it becomes more clear from different perspectives. So let's talk about what is artificial intelligence. So AI is computer systems that perform tasks typically requiring human intelligence. So these include things like problem solving, decision making, understanding natural language, recognizing speech and images. And an AI's goal is to interpret, analyze, and respond to human actions. It's there to simulate human intelligence in machines. When we use the word simulate, we're talking about mimics aspects, resembles behaviors. But what we're not talking about is emulation, which is replicating exact processes and mechanisms. That's if you created literally a virtual human brain. That's what emulation would be. So AI applications are vast and include areas such as expert systems, natural language processing, also known as NLP, speech recognition, robotics, and more. AI is used in various industries for tasks such as we're talking about business to consumer, so think of a customer service chatbot. If we're looking at e-commerce, think of a recommendation system. If we're talking about the auto industry, maybe we're looking at autonomous vehicles. If it's medical, then medical diagnosis. There's a lot of applications for AI, but it's a broad application for all sorts of things. Now let's take a look at generative AI. So generative AI, often initialized as Gen AI or said as Gen AI, is a subset of AI that focuses on creating new content or data that is novel and realistic. It can interpret or analyze data, but also generate new data itself. It often, so like types of content produces would be text, images, music, speech, and other forms of media. It often involves advanced machine learning techniques. So it could be using things like GANs. It could be using VAE, so variational autoencoders. A lot of current LLMs use the transformer architecture. So if you're using ChatGPT or Claude Sonnet or any of the popular ones, they're basically all transformer architectures. Generative AI has multiple modalities. And when we say modalities, it's like think about your senses. You have touch, taste, hearing, smell. So modalities are the kinds of content or senses that a model has. So we have vision, so realistic images and videos, text, generating human-like text, audio, composing music, molecular, which is more of an interesting one, so drug discovery via genomic data. And I want to make it clear again, we're talking about large language models, but LLMs, large language models, will generate out human-like text and is a subset of Gen AI. It's just one modality of the many modalities, but it's often conflated as being AI or Gen AI just because it's the most popular and in demand right now and the most developed. So just make sure that you understand that Gen AI and AI is not all about large language models. It's just one modality, one application of the broad sense of AI and Gen AI. Now let's just make sure we have a side-by-side comparison. And then I'm sure after this, you'll definitely know definitively the difference between AI and Gen AI. So in terms of functionality, AI focuses on understanding and decision making, whereas Gen AI is about creating new and original outputs. For data handling, AI analyzes and makes decisions based on existing data. Gen AI uses existing data to generate new and unseen outputs. In terms of applications, AI spans across various sectors, including data analysis, automation, NLP, and healthcare, where Gen AI, and yes, I see the spelling mistake, it's creative and innovative, focusing on content creation, synthetic data generation, deepfakes, and design. So there you go. Let's take a look at natural language processing, also known as NLP. And in machine learning, it's a technique that can understand the context of a corpus. A corpus is a body of related text, the text that you are working with. And NLP intersects with computer science and linguistics. So if you know a lot about the nature of spoken and written language, then computer science here is going to meet in the middle here so that we can make sense of it using algorithms. So NLP enables us to do things like analyze and interpret text within documents, emails, and messages, interpret or contextualize spoken text, like sentiment analysis, synthesize speech, such as using a voice assistant talking to you, automatically translate spoken or written phrases and sentences between languages, interpret spoken or written commands and determine appropriate actions. Another thing you'll hear a lot is language understanding, which is supposed to be, it's more like a specialized subset of NLP that just goes farther to understand more traditional, older ways of doing NLP. But anyway, what I'll do is we'll just take a look at this very simple flowchart to give you some idea of things that are related with an NLP. This is mostly just get you exposed to some terms. It's not important to remember what these are, and I can't even describe them off the top of my head. But again, just get you exposure to NLP terms so that when you see them later, you'll go look them up and be like, oh, I remember seeing that term here. So here we have like text wrangling, pre-processing, language understanding, so structure and syntax, processing functionality, which is what the NLP does for you in the end. But text wrangling pre-processing is where you are preparing text to be put into possibly a machine learning model, or maybe you're using it for some kind of analysis or something like that. And so this is basically taking text and formatting it, changing it. And so what could we be doing here? Well, we could be doing conversions. Maybe we're lowercasing things. Maybe we're uppercasing things. Maybe we're turning contractions into their full forms, or vice versa. Sanitation. This is where you are maybe stripping out HTML or special characters, or you are removing stop words when you have stop words later on in your ML models. Tokenization, which is converting the text into vector embeddings. We have stemming. Okay, we have lemmonization. So there's a lot of things here, but you can see it's mostly just like formatting the text to be utilized for something else. We have language understanding. So these are processes to make sense of the text. So part of speech tagging. So is this an adjective? Is this a noun? Things like that. Chunking. How can we break up the text and then work with those chunks later on down the road so that it still makes sense? Dependency parsing. So, which word relies on other words and what relationships do they have to other ones? Constituents parsing. Very hard word for me to say, but like imagine a traf green, and so like a noun has an adjective under it, which has another thing under it. If you look it up and go to Google Images, you'll know what I'm talking about. Then we have processing functionality. What are we using NLP for? So we have name entity recognition. This is where you have a body of text and it's highlighting important words, like maybe important nouns that it thinks you care about, or things like that, or personally identifiable information. We've got engrams, sentiment analysis. Is this text positive, negative, happy, sad? Information extraction. What are we trying to get out of a large body of text? Same thing with information retrieval. Questioning and answering. Topic modeling. So, again, not super important to know these in depth right now, but the things that are important, we will see these terms again, and you'll know what they are then. So don't worry about trying to memorize this now, but just get that exposure to NLP terms, okay? All right, let's compare supervised versus unsupervised learning. And I know we've already talked about it like twice before, but we're going to talk about it again and then again, because I'm just trying to give it to you in different perspectives so that you really know the difference between these. So let's talk about what is supervised learning. So this is a machine learning task or function that needs to be provided training data. And the training data is when you provide labeled data, the correct answers, and the machine can learn from those results. So show me how to do it, and then I can do it on my own. That's what's happening here. And so for supervised learning models, we have classification, regression. What about unsupervised learning? This is a machine learning task or function that needs no existing training data. For this, it will take the unlabeled data and discover its patterns, applying its own labels. So I am an independent worker. I can figure this out on my own, right? And for this, these unsupervised learning models, we really should have put the un on that there. Let me just fix that there. Unsupervised. We have clustering, association, dimensionality reduction. And so supervised learning tends to be more accurate than unsupervised learning, but requires more upfront work, whereas unsupervised learning still requires human intervention to validate the results. So hopefully that is clear, okay? take a look at what a machine learning model is. But before we do that, let's define what a model is in general terms. So in general terms, a model is information representation of an object, person, or system. Models can be concrete, so they have a physical form. Think a design of a vehicle, a person posing for a picture. Then you have abstract, so expressed as behavioral patterns. Think mathematical, computer code, written words. So what is a machine learning model then? An ML model is a function that takes in data, performs a machine learning algorithm to produce a prediction. The machine learning model is trained, not to be confused with the training model, which is learning to make correct predictions. An ML model can be the training model that is just deployed once it has been tuned to make good predictions. So normally you'd have training data, let's say labeled data, and here you are going to have your learning algorithm and you're going to put it through training. So that's your training model. And then you have hyper tuning where you are continuously tweaking the model to get it to where you want it to be. Okay. Then once you deploy the model, that is your trained model, your machine learning model, which can go and produce predictions. And from here, you could then provide it unlabeled data because, its goal is to make predictions, and that could be labeling data or doing other things, okay? And we call the interaction with the deployed machine learning model inference, right? So when you are inferring something, you are providing data and saying, hey, can you make a prediction for me? And that's what inference is, okay? So let's take a look at what a feature is. So a feature is a characteristic extracted from our unstructured data set that has been prepared to be ingested by our machine learning model to infer a prediction. So ML models generally only accept numerical data, and so we prepare our data into machine readable format by encoding, which we'll revisit later in more detail. So let's talk about what is feature engineering. So feature engineering is the process of extracting features from our provided data sources. So imagine you have your data sources, which you have then your raw data. You're going to clean and transform them into features, turning them into machine readable format information for your machine learning models. And then, you go from there, okay? So what is inference? Inference is the act of requesting and getting a prediction. And when we're talking about it in the context of machine learning, we're inputting data into a machine learning model that has been deployed for production use to then output a prediction. So imagine our raw data is a banana, and we say, tell me what this is to the machine learning model. It's going to bring back information. So it's saying it's a yellow banana and it has a confidence score of 0.9. So if we talk about the inference textbook definition, it's steps in reasoning or moving from premise to logical consequence, but I think that it's easy to remember it as the act of requesting and getting a prediction, okay? Hey, this is Andrew Brown, and we're taking a look at what is a foundational model. So a foundational model is a general purpose model that is trained on vast amounts of data. We say that a foundation model is pre-trained because it can be fine-tuned for specific tasks. So just remember, we are training the model, and we're going to say that it's a pre-trained model. But imagine text, images, video, structured data, all sorts of data, massive amounts of data that is going to produce your foundational model. And from that foundational model, it could do all sorts of things: prediction, classification, text generation. It might be limited to very specific things that it can do, but the point is that it can do a lot of things. And the reason I want to bring up foundational model is because you hear it a lot when we're talking about LLMs, and it becomes a bit confusing how to distinguish it between LLMs and a foundational model. But LLMs are a specialized subset of foundational models. They are foundational models that uses transformer architecture. So if you remember that LLMs are foundational models, but they're specifically using the transformer architecture, then that will help make a whole lot of sense, okay? Let's talk about large language models. This is going to be short, even though there's a lot you can say about it. I just want you to remember a key thing about large language models. So a large language model is a foundational model that implements the transformer architecture. And we're going to spend a bit of time learning about the transformer architecture in upcoming videos. But the idea is that you have natural language. I can get my pen tool out here. So we have natural language as our input. It goes to the large language model. It predicts output for words, and as it produces each word, it feeds it back in and continues to produce until it is done. So during the training phase, the model learns semantics or patterns of language such as grammar, word usage, sentence structure, style, and tone. That's what makes it so good at interpreting language and giving things that sound with language understanding, because it has that ability to understand the semantics of language. It would be simple to say that LLMs just predict the next sequence of words, because as you use the model, it outputs a word on the end of it and keeps feeding it in and in and again and in until it's done. But the honest truth is researchers do not know how LLMs generate their outputs, because there are so many layers and there's so much going on there that at this point right now, the level of complexity makes it very difficult to truly understand how it is reasoning its output. But it looks like it's just doing word for word, but there is a bit more to it, okay? But there you go. Let's talk about tokens and capacity, because it really matters about how much you can produce. So when using transformers, the decoder continuously feeds the sequence of tokens back in as the output to help predict the next word in the input. So what are we talking about here? So here, imagine we have our input as the quick. And so we feed into the encoder. The encoder is going to produce semantic context so that the decoder knows what to do with that text. And then the decoder is going to output the next word. So this is the quick brown. And what it does is it feeds that sequence of tokens back into the decoder and produces the next word, and again, and again. And so the question is, what is the capacity required to run this? And so there are two components that we care about: memory and compute. So for memory, each token in a sequence requires memory. So as the token count increases, the memory increases. The memory usage eventually becomes exhausted and you cannot produce anymore. Okay, so now for compute, models, a model performs more operations for each additional token. The longer the sequence is, then the more compute is required. So a lot of AI services that offer models of service will often have a limit of combined input and output, because it really has to do with the length of the sequence. So if you have a huge input, then you're not going to be able to generate a lot of words, because you're going to hit that sequence token limit a lot quicker. So hopefully that makes it very clear about how memory and compute are intertwined with tokens. The way cost gets down is, they have to figure out a way of reducing or making the model more efficient. So that's helping to reduce the memory compute. There's other things you can do. So if you have a conversation that gets too long, what you can do is summarize the conversation and feed it back into there. So it doesn't exactly use all of the context of what it had before, but it can do something similar and help that conversation along, okay? All right, let's take a look at how we can tune our prompt, so to speak, with some of these specific parameters. So you will see for basically all LLMs out there that you have these options of temperature, token limit, seed, top P. The only one that's a little bit different there is token limit, as some can say token limit for both the inputs and outputs, just on the outputs and just on the inputs separately. For whatever reason, Gemini is only on output token limit, which is totally fine. But let's make sure we understand what these parameters are. I do talk about them when we do utilize them, but just in case I did a poor job here, we're going to cover them again, okay? So temperature is the first one. So it controls randomness in the output. By the way, I don't write this anywhere, but the value that these normally set at natural is at 1, okay? Same thing here. This would be, well, it says 1 would be up here. So I guess top P would be 0.5. So I guess that one's slightly different, but for whatever reason, temperature here is at 1. So if you had a low value, so over here on the left-hand side, that will give you something that is more deterministic. If you have a high value, you're going to get something that is more creative. Taking a look at output token limit, this limits the outputted token response. So it's based on tokens, not words, but they kind of map to words in some degree. If you have a low value, you're going to have shorter responses. You're also going to have a lower cost. You're going to have faster response times. Higher value is the opposite. Longer responses, higher cost, higher latency for that response to complete. Sometimes shortening is good when you have something that's being too verbose, but sometimes it needs enough tokens to think, and shortening might stunt its ability to think correctly on its output. So you have to work with that. You have seed. Not all provide the ability to set seed, but seed initializes the modern random generator. Generally, having a seed in any kind of program can make it deterministic, because if you know the seed and you have the exact input, you should get the exact output. I don't know if it really works like that for LLMs, but at least this way, if you want a guarantee of more, I wouldn't say deterministic, but more consistency, you can set your exact seed and get more consistent results. You have top P. So this is the probability threshold for sampling output tokens. Okay, the keyword is sample here, like how much it selects from its outputted tokens, because it's not using every single one. It's going to choose from a selection of options. And so the lower the value, the more conservative the sampling is going to be, the more consistent your output is going to be. If you choose a higher value, it's more creative. Top P and temperature are very similar in terms of if you put them high, you get creative, and low. But the rule of thumb is you generally leave one in the center mark, right? One in the center mark, and then only tweak one. You don't normally do both, like dial both down to 0 or both to their maximum value, or one over here or one over there. You're not supposed to do that. Just one or the other gets moved and one stays in the default position in the middle. That's just the best recommendation. I can't tell you why. I just know that that's the case. But there you go, okay? Let's take a look here at zero-shot prompting. This is when the model can perform the expected task with no prior knowledge or examples provided during prompting. So an example might be that you want to classify some text. So the text here is, Andrew is great at teaching Gen AI. Do we classify it as neutral, negative, or positive? And so the output, the next thing that the large language model would write would be neutral here. But the idea is that we didn't have to provide it examples of what neutral, negative, positive looked like. It already had that built-in knowledge from when it was trained to be able to perform that task. And that's what we call zero shot. So few-shot prompting is when the model can perform the expected task with examples provided during prompting. So imagine you have a series of tweets and your model is not capable of doing sentiment analysis, so you're providing examples of what negative and positive tweets would look like, and the idea is that it would predict the next one based on the prior examples. We could also call this in-context learning, because you're providing in context in the prompt message the way in-context learning, because you're providing it at that point in time. So there you go. Let's take a look at prompt chaining. So prompt chaining is where the output of one LLM prompt is used as the input for the next prompt in a sequence. The reason is when the context window of the prompt is too small to complete a single large or complex task, so we break the task up into smaller tasks. So an example would be, imagine we have a movie that we want to watch, there's a movie that we want to watch to learn Japanese. And so we want to take the subtitles file and convert it into English, and then also get grammar rules around it, and then provide it in a JSON lines file. This is actually something that we do in the boot camp, and I didn't even realize I was doing prompt chaining when I did it, but I tried to give it a very complex prompt, and it just would not do it. It would just make a lot of mistakes or give me bad information. And so I had to break it up into smaller tasks. And so the thing I had to do is iterate over each line in the actual subtitles file, and say translate each line from Japanese to English. And then I would then ask it to produce a list of grammar rules that it found in the sentence. Then I would then ask it to explain the grammar rule and then provide 5 examples. Then I would format the original line, translator line, the grammar rule examples into JSON file. So again, this is just where you're breaking up a task because the LLM cannot handle such a large task, okay? Let's take a look at chain of thought. So chain of thought prompting is when you tell the model to do step-by-step reasoning so it produces a more accurate result. Without chain of thought, you'd say something like, which two prime numbers sum to 10? With chain of thought, you'd say, please solve the problem step by step. First outline your reasoning is clear. Logical chain of thought, then provide the final concise answer. This is not a huge issue for larger modern models, but the smaller models, sometimes they just don't know things unless they talk out loud and work through it. So sometimes you get extremely better results by just telling it to think out loud and think step by step. And so that's all that is really happening here, okay? Let's take a look at TPUs, which stands for Tensor Processing Unit. This is an AI accelerator that is an application-specific integrated circuit, an ASIC, developed by Google for neural network machine learning using Google's own TensorFlow software. It's hard not to talk about TPUs when we're also talking about TensorFlow, which we cover somewhere else in this course. TPUs are designed for high volume of low precision computation, and they've been making this since 2016. So at least from this time, at least almost 10 years, but we're getting close to there. And so here's an example of a TPU version 3 and a TPU v5p. So if you really like the TensorFlow framework, Google Cloud is going to be a great place for you to hang out because they have TPUs you can spin up there. But yeah, there you go. Let's talk about iGPUs, which stands for Integrated Graphics Processing Units. This is when a CPU contains capabilities of performing the task similar to a dedicated GPU. So an example might be something like the Intel Lunar Lake chip, which contains multiple systems, including iGPU. So here is a picture of the actual chip itself. Sometimes I like to say CPU for chip, but a chip can contain many systems. Obviously, it is a computing processing unit with other processing units within it. So if we look a bit closer, we can see the die cast, the actual pathways that are on the chip. And all these things actually map to very specific things, kind of like your brain, where one section is specifically for GPU. You'll also see IPUs and MPUs, which are all specific to AI stuff. So you can see that more modern chips, when we talk about AI PCs, these are the chips that we're talking about, have all this stuff built in to allow you to run AI models on your laptops, on your mobile devices. There is another term called DGPU, which stands for Dedicated Graphics Processing Unit. That's just your normal GPU, your normal graphics card. But sometimes you see that when you need to distinguish between iGPUs and DGPUs. How well do iGPUs perform? They actually perform extremely well, surprisingly. Obviously, a dedicated GPU is going to be better, but you can definitely get like a modern machine, and it performs just like the last or second last generation of graphics cards, and so it becomes extremely affordable and very good. So yeah, if you can get a machine that has an iGPU in it, you absolutely want to. But anything you buy these days generally should have them. But this is not limited to Intel. Obviously, AMD, Apple's Metal chips have them as well. So there you go. Hey, this is Andrew Brown, and let's talk about GPUs. I'm sure most people know what GPUs are here, but I'm going to talk about it anyway because I want to talk about CUDAs. So a GPU stands for General Processing Unit, and it's a processor that is specialized to quickly render high-resolution images and videos concurrently. If you've ever played video games, you know you need a good GPU because it's all about those images. However, GPUs can perform parallel operations on multiple sets of data, so they can also be used for non-graphical tasks. And this makes it really good for machine learning and scientific computation. So if you're trying to convince your significant other that you need a better graphics card, you can just tell them it's for work. I need it for machine learning and scientific computation. It's not your fault that you can also play video games with it. And so we have like a graphic there on the right-hand side. I think I got that from NVIDIA. And so they're kind of trying to demonstrate the difference between the parallelization with GPU versus serial tasks with CPU, but let's go and just read a little bit more. So CPUs can have an average of 4 to 16 processor cores. GPUs can have thousands of processor cores. How that works, I have no idea, but I just know that that's how it works. So we have 4 to 8 GPUs can provide as many as 40,000 cores. So that is a lot. GPUs are best suited for repetitive and highly parallel computing tasks, such as rendering graphics, cryptocurrency mining, if people are even still doing that, and deep learning and machine learning. So, there you go. That's GPUs. All right, let's take a look here at CUDA, but before we do, let's talk about NVIDIA. So NVIDIA is a company that manufactures graphical processing units for gaming and professional markets. If you have ever played video games and you build your own rig, a lot of people like to choose NVIDIA, but NVIDIA can do things other than video games. And this is due to their framework called CUDA, which stands for Compute Unified Device Architecture. So it's a parallel computing platform and API. I said framework, but I guess it's an API by NVIDIA that allows developers to use CUDA-enabled GPUs for general-purpose computing GPUs. And it says GPU because it's saying general-purpose GPUs. I know that's a mouthful there. So over on AWS, they have a bunch of instances that can utilize NVIDIA GPUs. So AWS is always changing the instances, so these could be old. But you can see we have a P3, which has the Tesla V100. You have the G3 with the Tesla M60, the G4 with the T4, the P4 with the Tesla A100. So these are probably old ones. There's new instances with newer NVIDIA cards. But my point is that AWS has GPUs that you can utilize. Another thing I want to point out with CUDA is that all major deep learning frameworks are integrated with NVIDIA deep learning SDKs. There's a big fight or war over these companies that make GPUs and CPUs because they really want theirs to be used for machine learning. So you can definitely be sure that AMD probably has some kind of similar offering or something, and definitely Intel as well. But NVIDIA has done a very good job in making sure that theirs is the most popular. So NVIDIA Deep Learning SDK is a collection of NVIDIA libraries for deep learning. So this is the SDK you can use with CUDA to interact with their API. So one of those libraries are called CUDA Deep Neural Network Library. So that's something you can use with it. And it's tuned for a bunch of stuff. If it looks like it's getting a little bit too technical, it's because this slide was for my machine learning AWS specialty, and I didn't do a whole lot to change it and brought it over. So you don't really need to know that last part there, but just understand what CUDA is and that it's very important for working with machine learning. And AWS has good offerings for instances with it, okay? Let's take a look at labeling. So data labeling is the process of identifying raw data, images, text files, videos, and adding one or more meaningful and informative labels to provide context so a machine learning model can learn from. With supervised machine learning, labeling is a prerequisite to produce training data, and each piece of data will generally be labeled by a human. On the left-hand side, that's an example of Amazon Rekognition, where it's trying to identify bounding boxes or classifying image under particular categories. That's an example of supervised machine learning that requires labeled data. With unsupervised machine learning, labels will be produced by the machine and may not be human readable. Then there's this concept of ground truth. This is a properly labeled data set that you use as an objective standard to train and assess a given model and is often called ground truth. The accuracy of trained models will depend on the accuracy of your ground truth. And so ground truth data is very important for successful models, okay? When we're talking about large language models, there's this idea of fine-tuning where if we have a model that we don't like it, we can do something to it to make it work a little bit better. To understand fine-tuning and the ways we can fine-tune it, let's just talk about the components that are involved in fine-tuning. And so we have to first take a look at hidden layers and its components. So when training, you have layers of nodes, also called neurons, so think like your brain. And between these nodes, there are going to be connections. And so connections are often between or across layers. But connections can also be within the same layer. And that's where we get this concept of self-attention. If you remember, the concept of attention is really important when we're talking about transformers for large language models. And I mean, if we represent it, it'd be more like it's connecting back to itself. And that's why we call it self-attention, because it's a layer that feeds back into itself, which is self-attention. Okay? But connections could also be where we have multiple sets of hidden layers. And these connections are computed in parallel. So the idea, I'm going to just draw this here, but imagine we have another layer with nodes, right? And the idea is that this one will feed into that one, but this one's coming from here. And so now it's called multi-head attention because it's coming from multiple sources. And in fact, some of these, they'll come all the way back here and go like this and feed in. So, that is ways that we can feed our data forward. Then we have parameters. So parameters are the weights of connections. So over here on the right-hand side, get my pen tool out again, we have a weight. And this weight is the representation of this connection between these two nodes. And so that's going to be a value. And so a connection might have one parameter, but they can also have multiple parameters. In most cases, it's one parameter. But you can imagine that for the amount of nodes that you have in each layer, they're going to have to connect to all the other ones in the next layer, and that's going to add up really quickly. Let's take a look at some transformer models or large language models and understand how many layers they're utilizing for training to get perspective. So let's take a look at GPT-3. So GPT-3 is not new. In fact, it is one of the smaller models that you can train still, like Babbage or DaVinci. If you go, like, let's say, use Microsoft Azure AI Studio and you want to do fine tuning, you can train GPT-3 models. And it has 96 layers, or at its large, and if we think about its parameters, that's 175 billion parameters. So you can only imagine how many nodes or connections are going on in there, but that's how many there are. And then we have BERT. So BERT has 12 layers or up to 24 layers. So BERT is still useful. It's a much simpler transformer that we can utilize. We have GPT-2, which has between 12 to 48 layers, so the same or more as BERT. Then you have Google's T5, which has 12 encoder and 12 decoder layers, or up to 24 layers there. So, if we're talking about fine-tuning, it's going to be tweaking the amount of layers, the amount of connections we're going to train, and things like that. But let's go define what is fine-tuning. So fine-tuning is retraining a pre-trained model's weights or its parameters on a smaller data set. So a model's weights is the outputted state of a model, but in this case, when we're talking about fine-tuning, we're talking about a trained model's output. Okay, so then what is supervised fine-tuning, SFT? This is where, when we provide the data set, it's already been labeled, right? So imagine we have a bunch of cats, or like photos of animals, and so we're labeling what each animal is, so that when the model is training, it's like it has a cheat sheet to know how to understand exactly what it is that it has. Okay, but so we're basically explicitly telling the model what the data is, as opposed to when we train our base model, that might be unsupervised, where we're not saying, oh, this is what this is, right? Because we're giving imagine trying to do supervised training on a huge data set, like labeling all. That would be very difficult. So the idea is that we will produce our base model first, or in the case of LLMs, the base model is the foundational model. So you're taking an existing model, a foundational model, and then we're going to train it. As soon as we have a foundational model or base model, and we decide to fine tune it, now it's being called a pre-trained model. Okay, so understand those terms. We have FM, okay, base model, pre-trained model. They're all in the same area. They don't necessarily mean exactly the same thing, but they represent the same thing at this place in time. So we're ready to take our base model and fine tune it. So we're going to bring in our smaller data set. I'm just going to clear all the ink off the screen here. And so the idea here is that we bring in that data set, and now we're going to train it, retrain it, and produce our fine-tuned model. Now, when I say we're producing these models or we're outputting these models, we're not actually outputting models, we're outputting the model's weights. Okay? We're not creating new models, we're just creating new outputted states of the model. And just understand that it often sounds like we're creating new code or something, but that's not necessarily true. So let's now talk about the types of fine tuning we can do, because there's a lot of approaches we can take to fine tuning. And this is not even exhaustive, but let's talk about changing the data set. So the data set itself, the data you're going to put in there, we could do instruction fine tuning. That's where we take a data set and we tell exactly what we want as, like, let's say I say this, you do that. So you're giving an example of what a person says and what the outcome is. So that's instruction fine tuning. Then we have domain-specific fine-tuning. That's where you're taking a knowledge base or a data set of specific knowledge to update the model on that knowledge, or to make it focus more on that knowledge set, right? So if we had a generic LLM and we wanted to make it specifically for learning cloud computing, I could load it up with the most up-to-date cloud data, or even my own stuff to make it teach like I would teach, okay? Then we have changing the method of training. So we have full fine tuning. This is where all the model's weights are updated, and it's expensive. So you say full fine tuning, we can just think of it as traditional fine tuning. You're basically taking the existing model's weights after the base tune as the starting point and running it through the training process again. Now you can add these two things together, right? You can do full fine tuning and change the data set. They can be done together or both separately. It's up to you. We have parameter efficient fine tuning, so also known as PEFT. You'll see this term come up a lot. It only updates a small set of parameters during the training and freezes the rest of the parameters. There is a subset of PEFT called LoRa, which we're not going to talk too much about here, but I'm just going to get you exposure to this. If you are not needing to update every single parameter, then you're going to save money there. Another way is last layer fine tuning. This is where you will freeze all the layers except the last layer. And when we say freeze, we just mean we're saving the state at that point in time, right? Or we're telling it to skip until it gets to the last step. And then we're basically just training it on a single layer. And apparently that works really well. So there's a lot of things that we can do. Another thing we can do is we can do pruning. So this is where you're removing parameters, all right? And people might want to do this just to make the model smaller and more efficient, because maybe we can remove parameters and it will use less compute or be faster for some trade-offs. And there's two ways we can do this. Train time pruning. So somehow we are making the model to encourage to drop or remove connections or neurons during training. Or post-training pruning, which is basically you mangling the model weights file, the file that's outputted. So yeah, a lot of options here, but there you go. So again, what is unstructured data? Well, it's just a bunch of loose data. Think of it as junk folder on your computer with a bunch of random files, not optimized for search, analysis, or simply no relation between the various data. So again, there's a bunch of files in my in one of my folders there. And so when we're talking about Microsoft and Azure services that store unstructured data, we have SharePoint, so shared documents for an organization, Azure Blob Storage, so unstructured object data store, Azure Files, a mountable file system for storing unstructured files, Azure Data Lake for big data. It's basically blob storage, but for vast amounts of data. And if I wanted to add a fifth one there, like Azure Disks, but that's more for virtual machines. Okay. So let's take a look here at semi-structured data, which basically has no schema, and the data has some form of relationship. It's easy to browse data to find related data, and you can search data, but there are limitations, or when you search, you will pay a computative or operational cost. A great way of thinking about this is think of a big box of Legos, and you have these Lego pieces. So it's not that there's not a schema defined. There's a schema defined in the sense of the Lego piece. So it can connect and make relationships with other things that are compatible, but overall, the entire data as a whole does not have a schema, right? You're not upfronting and doing data modeling. So just understand that's why I put the asterisk there. So there is a schema for the data structures, just not for everything in totally here. That's why it's called semi-structured. For concrete semi-structured data structures, we got XML, JSON, Avro, and Parquet. I don't know if it's pronounced Parquet, but that's the way I say it. And for Azure and other services that store semi-structured data, we have Azure Tables, which is a key value store, Azure Cosmos DB, where its primary one is document. Of course, it stores other types, but when we're talking about semi-structured, we're talking about a document store, MongoDB, which is an open source document store, and then we have Apache Cassandra, which is a wide column store database that's NoSQL. That's just an open source one, okay? All right, let's talk about structured data. So structured data, it has a scheme, and data has a relationship. It's easy to browse to find related data. It's easy to search data. The most common structured data is tabular data, representing the rows and columns, right? So examples here for Azure would be it's Postgres, Azure data SQL database for Postgres, for MSQL, Azure SQL for MS SQL, and Azure Synapse Analytics, which is the data warehouse service, okay? In the exam guide, they talk about security machine learning lifecycle, and they specifically are referencing a single page within the well-architected framework called AI ML Perspective. And there really isn't a whole lot in here, so I don't really know how this would align with the exam. I took the exam. I can't think of any questions that really aligns to it, but they had some key points, which was like define clear goals and requirements, keep data secure and prevent loss of mishandling, keep AI pipelines secure, robust against tampering, deploy an online secure system with secure tools and artifacts, protect and monitor inputs, monitor, evaluate, and prepare to respond to outputs. So you can look up this this single page paper. But again, I'm going to tell you there's not a whole lot in it, so I'm not sure how we're supposed to translate that over into exam questions. I never saw any on them, but if you choose to read it, just in case, you can go ahead and do that, okay? Let's take a look here at Google Secure AI Framework, which is a single page white paper on AI security within Google. I don't know why they have you read this, but they want you to know it. And we'll just look at the 6 points here. If you want to go and read the finer details, you can. I don't think it really helps, but it is an exam guide, so let's take a look here. So we have 6 core elements. The first is expand strong security foundations to the AI ecosystem, extend detection and responses to bring AI into organizations that to threat universe, automate defenses to keep pace with existing and new threats, harmonize platform level controls to ensure consistent security across the organization, adapt controls to adjust migrations and create faster feedback loops for the AI deployment, contextualize AI system risks in surrounding business processes. So again, I would just say that I didn't really see much in here. Like I can see even from here, they're talking about like SQL injection. Just get my pen tool out here. So I know it's really small, but we see like avoid SQL injection and then red teaming down below here. Somewhere there's red teaming. So you might want to give this a glance over, but to be honest, it's just common sense stuff. So if you have a technological background, it's going to be pretty obvious if you even get something that's remotely like this on the exam, but I wouldn't sweat it, okay? Let's talk about RAG Engine. So RAG Engine is a component within Vertex AI, but it's also a data framework. And so it allows you to transform your data to and from your vector DB storage of choice. And you can connect this to a third-party store, such as Pinecone or various other storage methods. And the way you do this is with an API. I believe when we cover the Vertex AI Search video when grounding, we're going to see some of this information with RAG Engine. And if you do set up a RAG engine, you have all these options where you can tweak the parsing of the document, the transformations, how it's indexed before it's inserted into the vector DB store. And then, when the LM is actually trying to retrieve information, you can change the way it's prepared, retrieved, ranking, serving. So there's a lot that you can do in between here. And so that's what they're talking about when they're saying this data framework. So on the exam, you might get a question about RAG Engine, and it's more just that it's a data framework and allows you to deal with the ingestion of documents, the retrieval of documents, and gives you data steps to do things with that data, okay? All right, let's take a look here at Vertex AI Search. So Vertex AI Search functions as an out-of-the-box RAG system. And when you're using Gemini, it has direct integrations with it. So via the API or via the interface, you can connect your Vertex AI search engine to perform RAG. And the thing that you need to know about Vertex AI Search is what it gives you out of the box. So let's look at a particular ones. The first one is custom search. So this is where you can have structured and unstructured data. You have connectors to different data sources. That could be Google Workspaces. That could be connecting things to BigQuery, to any type of storage within Google Cloud. It could be public sites and things like that. So think of any kind of storage on Google Google Cloud or Google Workspaces, you're going to be able to ingest that data into your search engine, your vector store, okay? Then you have site search with AI mode. So these are pre-built Google search indexes. So basically you're leveraging Google search's indexes and using AI in order to find structured and unstructured data. So just think of search results basically. Then you have media search, which allows you to search across images, videos, and audio files. I didn't walk through this one completely, so I'm not sure if it can pull things off of YouTube. So I imagine this would be data stored within your bucket or some kind of durable storage. And then you have search for commerce, which is retail search API. So you will get questions on the exam where they're like, hey, can you use Vertex AI search? And they'll like, what are some use cases? And one might literally be like search for commerce, and that would be the answer for that. There is another thing called Vertex Search, and it's a bit confusing, and I couldn't make sense of it, to be honest. There's no documentation on the distinction between Vertex Search and Vertex AI Search. Vertex Search, I thought, were the indexes and endpoints that Vertex AI Search was using, but it looks like maybe Vertex Search came first, and it's a more manual thing, or maybe if you set up custom search, that stuff shows up. So I'm not exactly sure what that is, but on the exam, they're not going to talk about Vertex Search. They're going to talk about Vertex AI Search, and you'll see in the lab that I'm a little bit confused about Vertex Search, which is fair because it's not in the docs and nowhere else, but there you go, okay? All right, so let's talk about what grounding is. So grounding is connecting the output of an AI system to something that is real and verifiable in the world rather than just generating plausible sounding text. And the great thing with Gemini is that you have this toggle where you can just turn it on and say, hey, let's ground against Google search. And by the way, when you have something that generates out plausible sounding text but is not correct, that is what we might describe as hallucination. So grounding is a great way to combat hallucinations from LLMs. Now, grounding isn't available on all models. I don't believe that Gemma would have it. So Gemma, which is a foundational Google model, is just the LLM itself, whereas Gemini is the model plus things built around it for convenience. And so we'll take a look in the next video where grounding is, but I don't believe Gemma has it, but we will double check. Now, here they're grounding against Google Search, and of course, Google Search is a great thing that you can ground against, but you can also go against Google Maps. You can also ground against your own data by using RAG. RAG stands for Retrieval Augmented Generation. All it means is it's just connecting to some kind of data store, whether it's a database or whatever. It's a very fancy term to saying, gonna go reach out and grab data and then give it back to the LLM so it has context. You can also ground with Elasticsearch. So that's obviously a great way. Elasticsearch is provides a full stack search engine, often used with vector store databases. So Elasticsearch, you see that a lot with not just Google, but all providers. And then you can do web grounding for enterprise. So this is an enterprise offering. I don't know much about it because I'm not running an enterprise account, but if you are an enterprise, they have some kind of solution there for you, okay? All right, let's go take a look and see if we can use the grounding feature, at least with Google Search. And so what I'm going to do is go into Vertex AI Studio under chat. I'm also going to go into Google AI Studio and see if they both have this feature. So over here, we're on Gemini Flash Preview, which is fine. And so what I'm looking for here is the options to ground. So if I expand this here, you'll notice that we have grounding with Google, and then you have grounding with your data. So we'll look at this one. If I need to do this, I'll do this in a separate video, but let's just look at Google Maps, as that's the simpler one. If you are in Google AI Studio, they'll also have it here under grounding with Google Search. But if you are on thinking mode, there are some restrictions where you might not be able to use it. So yeah, if you have structured output, you can't ground with Google Search. But let's go over to here and turn it on. And notice we have Google Search or Google Maps. I'm going to go with Google Search for now, okay? And I want to ask it something that is information-based, okay? So I'm trying to think of something that would be information-based that would need Google results. Today, there was information about bears in Japan. So I might go like, what can you tell me about recent bear attacks in Japan, okay? And so it's going to try to ground with Google Search. This is literally something I just read today in the NHK Easy News. And while that's searching, I'll just show you what I'm talking about. NHK Easy. I'm not sure if it would pull up exactly this. It'd be nice if it did. But see, this is talking about bear attacks. Of course, you need to know Japanese to know that. But we will go back over to here. And here it says recent, particularly 2023 at the beginning of 2024 has seen unprecedented bear searches. But I'm talking about 2025, like in the last 2 months, e.g. August, September, okay? So it says, sorry, I cannot provide you with specific real-time news updates for the last 2 months. Okay, but can't you search via Google search? Okay. Because it can ground, right? So it should be able to do it. Yeah, there we go. Okay. That's a fair request. I've performed a search from August to September 2025. And here's talking about Hokkaido, which is the north of Japan, which is totally possible. And here we have Akita and some other locations. And yes, even in Tokyo, they're having some issues. There's a huge conversation about gun rules. So yeah, there we go. So I had to, finesse it, but I got it to go. I'm not sure exactly how the other one will work. So if we go here, we have Google Maps. Give me a second to read and let's see how this works, okay? Okay, so this is saying that it's looking at spatial information like businesses, landmarks, point of interest. So this might be interesting to use this to look at locations. So I live in Schreiber, which is a very small town. And so I'm gonna say, can you tell me about local businesses in Schreiber, Ontario? And I'm curious if it'll actually use Google Maps here. So we're trying to pay attention here to the right-hand side and see if it references any information. And so here it is referencing information. So Highway 17, Roses and Josies. Let's see if it's at the map. That's the map. So it's pulling things from the map. And so there you go. That is grounding with Google Maps and Google Search. And we'll see. We might do this. We might not. This one might be really hard to do, but hopefully that gives you an idea of grounding. And there you go, okay? All right, so in the last video, we looked at grounding with Google Search and Maps. And the question is, can we set this up with a RAG engine or Vertex AI Search or anything that is from your own data? So this could be more involved and maybe it'll work, maybe it won't. But let's go ahead and give it a go. So I'm going to go ahead and toggle on. By the way, if you're watching, you don't have to do this. You just need to know how this works, as this could be very involved. I don't want this to be too complicated for you. I just want to go through the experience so we can figure it out. So we have RAG Engine, Vertex AI Search, and Elasticsearch. So Vertex AI is going to be a fully hosted service, which will make it really easy. Then we have RAG Engine. So I would assume that we adapt that to our own provider. So if we click on RAG Engine, let's take a look at what we have here. A data framework for developing context-augmented languages. So it looks like we're using an SDK in order to integrate it. So if we go over to here, actually the notebook will tell us a lot. If we take a look at the notebook, that'll give us an idea of integration. And so if we go here, we can see Pinecone feature store. So Pinecone, that's a third-party vector store. So if I go over here and type in Pinecone, we're not going to do this because it'll be too much work. But this is a service that specializes in storing vector data. Okay, so if we go in here and take a look, I'm assuming that this RAG engine is just an SDK or an API. So we go here, we're taking a look, we're carefully looking here. So we have Google AI Platform, so that's being brought in here. The Secrets Manager, we have Pinecone, and then Google Gemini AI. And so as we go and look through this code, I'm trying to make sense of it. Okay, do we see, we see Google Gen AI imported, Vertex AI, that makes sense. We're setting up Pinecone. And here we create the index. Okay, so what I'm trying to figure out is exactly how does it integrate, because Pinecone, and again, I don't want to go full on in on this, but Pinecone is a third-party provider. But when you provision a workload here, you can choose to put it in AWS, Azure, or GCP, right? So if I go over to here for a moment, we'll sign in. I've used Pinecone before. It's in my Gen AI Essentials course. But you can say, like, I want to deploy, but that's not within your Google Cloud account. That's within the managed version of this one. So you can see here I have a couple. I'm going to delete them since I'm not using these right now. Example index must match the name exactly, so we'll delete this one. And these aren't going to be used. That one's deployed to AWS, as you can see here in US East 1. So this is not the correct provider. But if we go here and we create an index, we should be able to say where we want to deploy it. See here? So here we could choose, I want to deploy this in GCP. And so that would allow us to connect a third-party provider here. So that's what it's specifying here. So we create the index. What I'm trying to figure out is how does it connect to it? Oh, and here it is. Okay, so rag corpus, rag pinecone. Okay, create the corpus, import the information. Okay. Grant your rag engine service account information. Just a second, okay? All right, so I think I figured it out. So see here where we're saying import rag from Vertex AI. So here we're saying rag. And then down below, we're saying that we're using Pinecone. So it has a direct integration to Pinecone here. And so now we have our vector database store. We're then connecting our Pinecone information, right? We're connecting our third-party Pinecone to here. And so that way our RAG engine is closely associated to here. And so again, this would be too much work to set up. Then you have Elasticsearch. Elasticsearch, very popular option for full text search. This is very involved, very expensive to run. If you're using AWS, I believe that their full text search engine, whatever the Amazon Bedrock, is actually spinning up an Elasticsearch instance underneath. So that's a very common way to do it. And then you have Vertex AI Search, which is a fully managed search engine. So it could be using Elasticsearch underneath. We don't really know as it's fully managed. But the idea is that it can be easier to create one. And I say easier because it's not exactly easy. It's very involved because you'd have to build it and set it up. But we can go take a look and see how far we could get with this. Again, I don't recommend you doing this. I would just say let's explore together and figure it out. I have spun up one up before, but it's been a while. But notice we have vector search and vector AI search. So vector search, is a search database. I would assume that AI would, actually, I don't know why it's that, because normally you'll have a full text search engine and then they will add AI to it to imply that it's a vector store. But just give me 2 seconds here. Okay, so I think what's going on here is vector AI search is the service, and then the actual indexes are listed here under vector search. I don't know why they just don't take the index tab and put it here. It'd be less confusing. But here we'll notice that we have some options. So we have custom search, site search, media search, search for commerce. So build a generative search with AI mode in a day using site content. That sounds pretty useful. And then over here we have unstructured data. So if you're on for the exam, you might want to know exactly what predefined ones are here. Okay, and all I wanted to do was see if there was more, but we got that weird thing here. But the point is, if you see these main 4 ones, that you can search against commerce, against the search API, that you can search against media, that you can search against a specific website, or if you want to do custom, that's all you need to know. But let's go ahead and try this middle one here. So it's allow to sample data. Sure, we'll go ahead and hit yes. We'll give it a moment. The only problem here is that I'm concerned that the Vertex AI search might take a long time to set up. A lot of times these things take forever to get going. But again, for the exam, I'm going to again recommend that you just remember that Vertex AI search can do those 4 things, because that's all you're going to get on the exam. They're not going to be like, how did you configure a Vertex AI search? They're going to ask you something like, can you search e-commerce with it, right? Just give me a second here to review this. Just before I spun it up, I just wanted to take a look at the cost of it. And if you see here, we're talking about the data streaming, and it's talking about Bigtable. But that says Vertex, we're down here, Vertex Search, right? Oh, over here, there we go. This is better. That other one didn't make any sense. It doesn't use Bigtable. And so here we see that it's per node hour per billing VMUs for deployment. Okay, and so these are in the sense. So when I see something in the sense, that makes it a little bit easier for me here. If we go down below, if we have a number of embeddings is 2 million with a number of dimensions of 128, then we have $68. I've seen embeddings or dimensions go up to 1024. So these numbers seem a little bit low to me. I guess my question is, I just want to know if I spin this up, is it going to be really expensive or not? And that's what I'm trying to decide. And we also have a bunch of enterprise features. So here it says, in addition to standard features, you'll get this stuff. I don't need that here today. For structured, unstructured, advanced web search, you get summarized search. I'm going to turn that off as well. I'm going to go ahead here and just say my vector search. Again, I recommend you not do this and just watch me do it. Exam Pro Training Inc. Provide the company name for high quality models. Global seems fine to me. We'll go ahead and hit continue. And then this is where we need to actually upload our data. So we can go here and notice it has predefined options for us. So we can get information right away. We can ingest data from BigQuery, cloud storage, cloud SQL, all sorts of places. So if we want to build our RAG quickly, the integrations are right there. Let's go to website content. And here we have sites to include. One site per line, HTTPS is not needed. So I'll just put exampro.co. There we go. I don't need advanced anything. We'll go ahead and do that. Enter a data store name, ExamPro website. We'll go ahead and create. Again, just watch me do this. You don't need to do this yourself, okay? One data store is currently unavailable for this app. Why? Connected apps. A website data store can only connect to an enterprise edition search app. Well, that's great. So I guess that is, we needed that other toggle there. So we'll go back here for a moment. And I don't think it created the app. Go to data stores. So we have the data store here. Let's go back and create the app. And we'll go back to site search with AI. We'll leave this one checkboxed on. I'll leave that off. We'll just say Exam Pro Training Inc. And we'll go ahead and hit continue. Say Exam Pro Search. Continue. And now we can just select that and it should connect to it. We'll give it a moment here. And so now we have a bunch of these options. So notice that there's a bunch of stuff. There is a bunch of stuff going on here. So these are high-level stage of components. Okay, we'll go ahead and hit preview. Normally when I use Vertex AI Search, I don't use this feature. I just import from a database directly. It's easier, but I'm trying to do something that's going to make our lives a lot easier. Just give me a second here and see if I can get it to move along, okay? All right, so I'm just playing around with the preview, and so I just typed in AWS, and notice that it's anchoring everything specifically to this. So it is using search and working pretty well here. So we'll just say multi-packages. Let's see if it can handle this. Wow, that's really nice. Okay. Cheap courses. Again, I'm just trying random things here to see what shows up here. Google search. Okay, so I guess it depends on how good the stuff is indexed or stuff like that. So do we need to do anything else for this? I don't think so. I mean, like, there's all these options here. I guess we'd have to click through each ones and configure them. Yeah, so notice here, like, we have like an entire pipeline here. So I guess you'd have to click through every single one and adjust it. Okay, so I guess the takeaway here is that obviously there is like guardrails kind of built into here because you can filter out information. You can adjust all sorts of stuff, but on the exam, they're not going to ask you any of this, right? They just want you to know, like, can you use the API? Let's go back over to here for a second, and let's see if we can actually now attach that Vertex AI Search. Okay, I'm going to give this a hard refresh. I just want to see if it'll auto-populate because I really don't want to have to fill that in manually. And we'll go back and we'll expand that here, sorry. And then we'll go and turn this on here. And so, yeah, we'd have to list it exactly. That's kind of frustrating. Let's go over to our data source here. Okay, so projects, locations, collections, data source. Let's go back here. Data stores, here we go. And so I'm trying to see if I can just get the full address here. Not easily, but we do have the data store ID. So if we come back over here, we have projects. Well, it doesn't show us the whole thing here. So we have projects, whatever our current project ID is. So we'll go over to here and I will grab our project ID. Don't you just love it? Sometimes they give you convenience and other times they don't. Locations, whatever location we're in. I think it's global. We will go back here. I think it's global here. Then we have collections. What is the collection name? I think it's default collection up here, so we'll go ahead and grab that. And then we have data stores. I don't know why all of a sudden it's using casing like that. And then we have the data store name. So we go over to here. There's nothing that says name. There's the ID, and then there's the name here. So which is it? Is it the name or the ID? We don't know. And so we'll go over to here, and we'll try that. I mean, it looks like it took. And so let's go ahead and say, can you tell me what Google certifications are available on ExamPro? And let's see if it actually references it. So hopefully that works. It says that it wasn't found. So we'll go back here for a second, and let's adjust this with the ID here, because that makes a little bit more sense, not the name. Collections. So let's take a look here. So we have projects, project ID. Locations. There we go. I'll just copy and save that. We'll try that one more time. And so you can see that it's trying to hit that there. If it doesn't work, that's totally fine. But you have an idea here. But sometimes these things are easy to do, sometimes they're not. It looks like it is working this time. Okay, we'll give it a second here. All right, and so we're getting some results here. The question is it looking? Okay. So, whoops, I didn't mean to exit out there, but we'll go back here for a second. Did you use vector search AI? Because it seems like it did. No, I did not. Can you? Can you please? And now we get that problem where I can't see what we're doing, so we'll give this a nice refresh here. Okay, let's say, can you are connected to Vector Search AI. Can you please search ExamPro to ensure the latest and not just based on your internal knowledge? Okay, because it should be able to do that. Sometimes we got to encourage it, like we use Google Maps here. Okay, but so we'll go back here. I hate that it keeps doing that. I'm not doing anything to cause that. So we'll take a look at tools here down below. Sorry, but you can. And so for whatever reason, I can't seem to get it to utilize it, but it clearly is connected as we've configured it. And sometimes this is a bit of the challenge is getting it to prompt, but we noticed that before with Google Maps where or not Google Maps, but Google Search, that it didn't search and then I had to encourage it. But yeah, hopefully that gives you an idea. But remember, the takeaway here is for Vertex, and specifically Vertex AI Search, is the fact that you have these options, right? And it can search commerce. It can search media. It can search in AI mode with the sites. You can give it custom stuff connecting it to various things. So hopefully that is clear. Before I move on, I'm just going to do a bit of cleanup. So I guess we do have indexes here. I thought when we create the indexes, they'd show up under here. But I suppose we could also create indexes under here. So I guess they're not related, and Vertex Search is something completely separate. But I want to go to my existing apps. I just want to clear these out. So we'll go ahead and I'm going to delete this and say yes. And we'll go over to data stores and we'll go ahead here and say yes. I'll see you in the next one. Okay. Ciao. Model Garden is a model catalog showing available models and their model cards, basically the description of the models that you can use within GCP. This is really straightforward. So within Vertex AI on the left-hand side, you're going to see this little thing that looks like a plant, and we're going to have a list of models that Google has. So they have their foundational models, or Google models here, partner models, and then models you can deploy, and they break them down by task. They do show you other ways that you could deploy these models. So I guess like with Hugging Face or other means like directly onto Vertex AI. Other providers generally call this a model catalog, but for whatever reason, Google calls it a model garden, as the Google's being Google with their naming of things. But this is generally called a model catalog in every other provider. But yeah, you can click into them and read about them. There's not much to say here, but you just need to know what a model garden is, and that's where you can see a selection of models, okay? All right, let's talk about Google Gemini versus Gemma, as these seem very similar, but there's some key differences to it. So Google Gemini is a closed model, meaning that it's a fully managed model by Google that is only accessible over an API, is multimodal, meaning that it can handle multiple modalities, taking image, audio, text, whatever the model. There's variants of the models, but for the most part, be able to insert image and text, and sometimes audio. It has proprietary API integrations such as grounding, JSON structured outputs, and thinking mode, and more stuff. Let's take a look at Google Gemma. So Google Gemma is an opens weights model. You can run the model on your own compute, so that's the huge advantage there. Older models are text to text, so they're only a single modality, but the newer models, I think at least Gemma 3, is multimodal. All you get is the model, so you need to build your own integrations around the model. But if you need to run something in an air-gapped environment, or you have to run it on-premise because you're concerned about cloud storage, there's many reasons as to why you'd use Gemma. So those are the two comparisons there. And there you go, okay? Hey, this is Andrew Brown. In this video, I want to make sure that you understand the clear difference between Gemma and Gemini. So these are two types of foundational models. Gemini is a fully hosted, fully managed foundational model by Google that you have to use through one of their APIs, whereas Gemma is a open weights model that you can download and use on your machine. And it might not have the same capabilities as Gemini, but it's still really, really good. So when you are here in Vertex AI, I want to just show you here, and you go to Vertex AI Studio, and you want to create a chat, you're going to notice here that we do not have Gemma. We have Anthropic and some other ones, but notice that I can't find Gemma. We'll go ahead and search there. And so for whatever reason, they don't make the model readily available here in Vertex AI Studio. They want to emphasize Gemini. If you go over to Google AI Studio, which is Google as well, and you go take a look here, you can actually access Gemma. Okay, and so we have a variety of Gemma models, but the distinction that you need to know is that Gemma is an opens weight model. You can download the weights and run it on your computer, whereas Gemini, you cannot. And so to make that really clear, there's a program called Ollama. Okay, and Ollama is a program that you can download and install onto your computer. I'm not sure if I have it open right now. Let's see if I have it open. I'm going to open it up. Okay. And I'm just opening up Ollama off screen. But while that's opening, I just want to show you that we can find Gemma here. Okay. And I can download Gemma to my local machines by running Ollama Gemma 3. And I can utilize my local compute in order to use Gemma. Okay. So that is the clear distinction, is that Gemma allows you to download it. It's open weights. It's not going to have the same capabilities as Gemini. But it has more portability, and often you'll need to load the model and integrate it. Whereas Gemini is accessed through an API. It has a lot more additional functionality. So Gemma is straight up just a model, where Gemini can have additional API endpoints for different kinds of integrations. And this might be more clear in Vertex AI. So I'm just trying to see here. Maybe over here. Let me go and switch back over to Gemini. So we'll go Gemini Pro. And notice here, Gemini Pro, we have a bunch of options. We have structured output, something we can do. We have thinking mode. We have code execution. It might not be for this model. If we go over here, maybe to Gemini Flash. Latest. Okay. Maybe I've turned thinking mode off here. Grounded search. Now I can turn that on. So we have additional functionality because it's not just a model. It's a model packaged with other conveniences. And so, if you are a company and you just need to hit the ground running and there's no reason for you to run the model locally, there's no security concerns, then you can use Gemini. It's really, really good. But if you need to know exactly where the model is running, maybe you need to run an air gap environment, maybe you just don't trust cloud storage for whatever reason, so you can use Gemma. You're going to have trade-offs where you're going to have to build a lot of this functionality out yourself, but you're going to have. And so that is the key distinction between Gemma and Gemini. So hopefully that is clear, okay? All right, it's Andrew, and we are back. And what I want to do is compare Imagen and Veo. So these two things manipulate images, but one is focused on video. So Veo is focused on videos, or Imagen is focused on images. If we're in Google AI Studio and we click here on the right-hand side, you'll notice we have option for images, and it's only showing Nano Banana. Nano Banana is a newer model, part of Gemini 2.5 Flash images, and that's because some models are multimodal, meaning that they can accept more than just text. They might be able to accept images or videos or audios or things like that. But the point is that Nano Banana can take input as text or images, so it's able to do more than just. All right, I want to talk about multimodal models. So multimodal means that a large language model or a foundational model is able to accept multiple modalities. What is a modality? A modality is what its input or outputs could be. So that's when it can take more than one kind. So if it can take text and audio as input, that's multiple modalities. If it can output more than two types, then it's multiple modalities. If it's a mix on both ends, it's multiple modalities. And so some models are multimodal and some aren't, okay? And the way you find that out is you explore. So if I'm in Google AI Studio, we could do this in Vertex AI as well, and we go over to Gemini, okay? And we take a look at, it's still on Nano Banana, but it's probably because I didn't select anything. We can kind of click around and see here where it is. So what I'm looking for is one that might not be multimodal, okay? So I'm not sure. They might all be multimodal at this point, but let's go ahead and say, like, we'll ask Gemini Pro. So does any of the foundational LLMs from Google is not multimodal? Okay, let's just see if we can identify one here. I know it's not the best sentence, but it's the best way I could think about it. We'll give it a moment here to think. It's coming back with some results. So not multimodal text only. So here are some really old ones. We have LAMDA, Palm. These are really, really old. We don't use these anymore. Then we have those ones. And so basically they're suggesting that Gemini is multimodal. So it can take in multiple inputs. And so right now we just gave it text, but we could also give it an image. So we might go here and we might just say banana. Here's a picture of a banana, right? And I'm just going to copy to my clipboard, and we're going to paste it into here. Okay. Can you tell me what this is an image of? Okay. And it should be able to tell me that it's a banana, and that means it's accepting an image, and that makes it multimodal. So we'll give it a moment here to see. Okay. It's going to do some analysis. We'll give it a moment. And here it suggests that the image is a banana, and it indeed is a banana, so that is perfect for us. So you need to know that Gemini, I don't think there's any Gemini model that's not multimodal. I think they all are, but some other competitors at some point, like OpenAI, some of their old ones just, that were called like GPT, were only text only, right? But for most part, almost all new models are multimodal. The question is Gemma multimodal? Because sometimes with these open weight ones, they don't have those capabilities. But let's take a look here and see. So we have one here. This is visual and text input. So you can tell that Gemma 3 is multimodal. And if we keep carefully looking here, no, they seem like they're all multimodal. So one thing I might want to take a look here is Gemma. And let's take a look at some of the older versions of Gemma. So here it says, yeah, we'll go to this one here. So maybe Gemma 1 is this one only. So it says family of lightweight used to create Google Gemini models. They are text-to-text decoder only language models. So this one here is not multimodal. All it has is the ability to produce text. So Just know that most modern ones are multimodal. Gemma 3 is multimodal. All the Gemini models are multimodal, but maybe with Gemma 1, it's not. Let's take a look at Gemma 2. Let's see if Gemma 2 is text only. So we'll go here and take a look, Gemma. And so here, this is text-to-text decoder only. So Gemma 2 is text only. Let's make sure and take a look at 3. So we look at 3. And this one here is multimodal. Okay, good. If we go back and take a look at our models here, there are some like weird variants of Gemma. Let's take a look here. So we have 3N. So is 3N text only? No, this one's multimodal as well. So hopefully that is clear what the difference is, but there you go. Let's take a look here at Agent Assist that provides in-the-moment coaching and next-based action guidance to customer care representatives, helping them resolve customer issues faster with greater accuracy. I like to summarize this as a real-time, on-the-call AI support for your human support team. It has many options, but the key ones is summarization, knowledge assist, and smart reply, so you can understand what this does. To be honest, if you just remember that this is just support for your support team, then you'll get the points you need on the exam. But let's take a look here. So key features is we have summarization. So automatically summarizes customer conversations. So as the agent is talking to the customer, it's going to then summarize in a very particular structure that you want it to. So you might want it always to extract out the tracking number if it gets mentioned, or the delivery status, or the sentiment of the customer, things like that. And you can add your own sections of what will get summarized. Then there's Knowledge Assist. This is just allowing your human agent to talk to an internal agent, which is just Conversations Agent. And we'll talk about Conversations Agent in its own slide, but yeah, this is just your human agent talking to an AI agent that the customer is not aware of. You have Smart Reply. So this suggests contextually relative messages to the agents while they're having a conversation with a customer. So these are just suggested replies. To set this up, you need your own large data set that you put into cloud storage, and then it trains based on that data set of examples. The training takes 8 to 24 hours, which is insane. So this is probably doing full fine-tune training, as opposed to something like LoRa, low adaptive ranking, or whatever the LoRa training, which is a lot faster. And so I tried all these things. Summarization worked perfectly. Knowledge Assist is a little bit hard to set up because you need to know Dialogflow CX, which is very, very complicated. And then you have to upload documents somewhere. So we have an idea of how that works. And then Smart Reply, I'm sure this works, but it's just very expensive, very slow to run. But if you are a data center, I could see the cost would be worth it, okay? All right, so I want to show you Agent Assist. You're just watching, not necessarily doing, but we're going to just understand the feature set behind it. So I'm in my Google Cloud account, but it's actually easier to find this if we just type in Agent Assist, and we type in where we go down to the service page here, and we go to its console, because it seems to have its own little ecosystem here in the Google Agent Assist. So here you can see Agent Assist, conversational insights, all the things that are around the engagement suite. So let's go take a look at how this might work. You do have to have projects within your GCP account. So I have one called GCP Playground where I've been using everything. As you use this stuff, it'll probably ask you to activate things, but we can figure it out as we go. You can see the key features is summarization, knowledge assistant, and smart reply. There's this new one called build your own assistant. That is just a customizable version of knowledge assistant. That's why we're just focusing on these three here. They do have a simulator here, so you can start simulating a conversation. Again, you have to tie this to a specific Google project, and you need to have a conversation profile. So let's make our way over to conversation profile and make a new one. So I'm going to call this simple convo profile. And down below here, we have suggestion types. So these are the things that this will activate during the conversation. So content summarization sounds really, really good. It seems like we need a generator. So I'm not sure. Maybe we have to make those before we use them. So let's discard that for a second. And we'll go back over to here, leave without saving. And let's just create a new generator. So we'll zoom up. So pick how the summarization feature will be powered. Sounds good to me. So we'll go start. There's only like one option, so I'm not sure what else it would do here. And we'll just call it simple generator. Okay, we will lock that down to English. We'll use the latest version, which is all we have. Let's look at some of the predefined sections. So what the customer needs help with, what the agent does to help the customer, resolution, and we have other options down below. So that seems fine. So, and then we have few shot examples. So I guess we could add examples if we wanted to make this more specific. Let's go ahead and save that. And use the chat inputs below, upload a conversation file JSON with more than 300 message. So what I'm going to do is I'm going to go over to the Google Studio AI playground, and we're going to just generate a conversation and see if we can utilize it for that. And let's take a look at what format it wants for that. So we'll go over to here. I'll go back to Google AI Studio. I want to make sure that I'm on Pro. And I'm going to say here, I want to generate a conversation for JSON file to test out generator in Agent Assist. Okay, so make me a conversation. And we'll go ahead and run that. We'll see if this works. Be back in just a moment. We are back. We have some conversation here. So we have ordering query. I'm calling about the status of my order. Can you help me, et cetera, et cetera. So I'm thinking the format's probably right. I don't know for certain, but I'm going to go ahead and download that file there. We're going to go back over to here, and I'm going to upload it. So just give me a moment to upload that file. So I'm just doing this off screen here, but just give me just a moment as I'm looking for that file. All right, so I just uploaded the conversation in here. So I had to rename it as JSON file, but it says, hello, I'm calling you to check the status of my order. Of course, I can help you with that. Let me pull up your order details. It looks like your order has been shipped. It's scheduled. That is great. Certainly, this is the tracking number, et cetera, et cetera. So we filled that out. Now let's take a look at the generated output. So I'll just make this a little bit larger. Maybe expand that there. And so situation, the customer wants to check the status of their order with the number. Agent, the agent confirmed the order has been shipped and is scheduled to arrive the next day. The agent also provided the tracking number. Resolution is Y. I don't know why. I guess Y as in it has been resolved. So that looks really good there. Let's go over to here and let's add customer satisfaction to our list here. And we'll click generate and see what happens now. And so it says, has the customer been satisfied? No. But it says, I thank you so much for your help. So I'm not sure why they decide that they're not satisfied, because they clearly are. They didn't cancel for any reason. Key entities extracted. Let's try this one out, generate. Okay, so there's the order ID. So there you are getting some kind of summarization information. And I guess we could add our own custom sections. So we have predefined sections. Maybe we'd want to, well, they have the entities here, but I mean, like, again, you could be like order status, like this, and defines the current status of the order. Okay, we'll save that. It's generating. And now it says it's shipped. So that is a way that we can get summarization. I'm going to stop the video here so I can capture this and go through each things here. But the simulator is just going to allow us to see that in real time, but we'll come back to that in a moment. But that's summarization. Let's see if we can tackle those other ones, okay? All right, now let's take a look here at Knowledge Assist. So I'm going to make sure I select a project. And before we can utilize this, we need to create an agent. So I'll go ahead and create one. The nice thing about creating an agent here is that they have a bunch of pre-built ones. So that'll work perfectly for this. We're using Conversations Agents, which is an upgraded version of Dialog CX. And we could create our own agent, but it's really complicated. So let's go ahead and use a pre-built one. And so probably the use case of a pre-built one would be order management, because we were talking about tracking numbers before. And we can just go ahead here and import this agent. I'm going to import it with the default settings, as it's totally fine. And so Dialog CX existed before LLMs, and the purpose was to basically define a very complex if-else statements and use some kind of pattern matching in order to figure out the intent of the user. These systems are still fine. They're very cost-effective comparative to LLMs, but you can see that they're really complex. So here we have a bunch of flows, and if we click into that, that has a bunch of flows, and then we click into that, explains the decisions of how it does routing. So if we click into here, so we have the handoff. So routes are called when the end user inputs a machine intent or whatever, which makes sense. So they've put something in here. And then there's an intent category that it knows to hand it off. Right? So it's really hard to show you this without really basically teaching you dialogue flow CX. It's really complicated. And somewhere in here, there are LLMs inserted into this. And you can even see dialogue CX has been upgraded to the conversational agent. But the point is that for the certification that we're targeting, it's enough for us to just know that there's this complex system and that it uses LLMs, and there's pre-built ones that we can use. So now that we have ourselves a conversations agent, let's go back to Agent Assist. And in here, we'll go to Knowledge Assist. Okay, and so now we have an agent we created. Let's go set up the feature, which we're now setting up a conversation profile. We need this if we want to use the simulator, which I think we were trying before. But if we want to use it here, we have to use it now because it doesn't seem to have its own little preview interface here. So we'll just go simple convo profile. And I'm going to go here and checkbox summarization because we have one, right? So we'll get that one in here. And now for Knowledge Assist agent, enter a valid data store agent. Well, we created one, so I would have thought we would just select it here. Just a moment. Maybe this one doesn't autocomplete. Let's give this a hard refresh. Sometimes when they make the UIs here, they don't make everything super simple. Simple combo profile. And obviously we want the generator one because that one's good. This one's not autocomplete anything. So disable agent search query against logging, et cetera, et cetera. Data store agent. So maybe it's because we are in global and this is US Central. Data rests in global. So what I'm going to do is I'm going to go back over to here to, leave without saving. And we'll create another agent. And this time what I'll do, I'm going to delete this one because we didn't do anything with it, which is fine. I'm going to create an agent. I'm going to make sure that we are, whoops, no, I don't want that. We'll go into here and we'll select it again. And I'll make sure that we go into global this time. So we'll drop it down. And notice that we have US multi-region, global right here. Okay. And so we'll go ahead and create that. And then this way we'll be able to select it and create our profile. So we'll give that a moment to create. And what I'm going to do here is go back over to our Agent Assist. And in here we'll go into Knowledge Assist. And we'll set up this feature. I'm going to go ahead and select the summarization. We'll just say my simple convo profile. And now we can select it, okay? So we have that. It says show all suggested queries from conversations. I'm not sure if we care about this. Sure, why not? Let's just do that. I don't think I care about that. That's fine. And so that's good enough. There's other features that we can enable here, like enable sentiment analysis, which is not a bad idea. You can leverage Mol's create an agent assist to create a dialogue flow. I mean, basically, we just made a dialogue flow, so I'm not exactly sure why that's separate. Looks like there could be some security options. I'm not really sure what. Let's go ahead and create that profile. And so now that we've created that profile, if we want to use it, I guess we go over to the simulator. Okay. And we'll choose that there. And it would have been nice if we could start a conversation, inject something here, but I'll just say, hello, I have shipped. I haven't received my package yet. Okay. And notice as we're doing this, it's starting to show some. So track package delivery status. So as the customer support, I have that information. Oh, sorry to hear. When did you? Sorry. Do you have your tracking number? So go ahead and do that. Yes, my tracking number is N43, N3, D3, G21. Okay, so we'll hit enter. And again, I'm just waiting to see if this thing is going to trigger it. Let me look up that tracking number. Okay. So what I was hoping for here, I was hoping for the knowledge assist to come in here, which it hasn't done anything yet. So I'm not exactly sure. Maybe it's not doing exactly what we thought it would do. Oh, let's try it out over here. So I thought with the simulator would work. Yeah, so it's the same thing, right? Ask a question or search. Okay, so maybe this. So like, hello, I have a problem with my delivery. Sure, let me know what the issue is. I haven't received my package yet. I ordered a toaster. Okay, we'll go over to here. This is basically the same interface. We have this up here. So troubleshoot delivery issues, track package. So ask a question or search content. So how do we resolve a refund? No search for found. Okay, so that's not really helpful, but we'll go back over to our conversation agents. Because it said like, well, we can upload files. But that's not really going to help us here. Search flow. So here, maybe like we have something where it's like search the store. But how would it know about that data? So I think this is going to be kind of hard to show because I don't have the associated data with it. But in theory, the way this should work is that, you know, if I type this, if I like someone can't find something, I'm like, you know, how much do our toasters go for? Toasters cost in our store. You know, in theory, I should be able to type that and it would go through the flow, right? And if I knew my flows, I'd be able to get that information. But to be honest, it would take me hours to set up a demo for this. And so I think what you just need to know is that if you set up an agent properly and you type questions or ask questions, it will provide information on the spot. And that's what it'll do, okay? So that's the best I can do there, and I think that's sufficient, okay? Ciao, ciao. All right, we are back. Let's take a look at Smart Reply. So Smart Reply will allow us to have good suggested Smart Replies. Let's go ahead and create a custom model. Just say my Smart Reply here. And then we have prepare your data, create a conversational data set, train the model, evaluate. Well, that sounds like a lot of work, but we'll go ahead and see what we can do here. I have not uploaded any conversation transcriptions yet. I have uploaded my transcriptions in Google Cloud Storage. I have an existing conversation data set. I would like to try sample data set. Let's go ahead with sample and we'll go next. So there it's including the data set. We'll create the data set. And by the way, I just recommend watching because I don't know what the costs are involved with this, especially when we talk about training. These things can be really slow, but it depends on what the underlying training strategy is. Maybe it's using LoRa, which is a very fast, cost-effective way of training models. But we'll go ahead and let this data set import. I'll be back in just a moment, okay? All right, so I just want to show that this is going to take a long time. So even importing the data, I've been here for, I don't know, 15 minutes, but it says it'll take 8 to 24 hours to train it. So I don't want to do this, but the point is that you would train it, you would use it, then it would be smart enough to give you smart replies. I think it's pretty straightforward what this thing is doing. And there's no way to cancel this. So I don't recommend going through this unless you really want to do it, as it will take forever. But at least we had a chance to look at smart replies, okay? All right, let's take a look here at conversation agents, also known as Dialogflow CX. Technically, Dialogflow CX is the old one, and then they say it's upgraded. I'm doing air quotes here to say upgraded to include large language models. So it provides proactive, personalized self-service and natural human-like voices for highly engaging customer experience. It's an agent that replaces the role of a customer support human. That's basically what it is. It's literally a chat bot, but now it's an agent bot because they've integrated LLMs. So here's an example of a dialogue flow. And it's a lot more complicated than what you're looking at because each of those defines a flow. And then inside of that, it has its own flow. And then inside of that, it has intents of what it can do and stuff like that. So I like to think of this as like a big if-else statement or like a very complex rule system. But anyway, the takeaway is that this is an AI agent and it has these steps, and this is what you're going to have when you want to have a person talking to an agent. For this exam, you do not need to know how to make one. They are just way too complicated, but you should know that they do have predefined templates that you can utilize, because an exam question might ask you like, hey, if you're using Dialogflow, CX, or conversational agents, why might you want to use it? Well, that's because they have a bunch of predefined templates and they can get you going right away, okay? All right, so here I am in conversational agents. So you just look it up and you find it here. And we made one before when we did the agent assist. So I'll just go into here very quickly and we'll just poke around. We're not going to create one fully because it's too complicated, but there's the pre-built agent, build your own, or create a Q&A one. So the pre-built agents is the best recommendation, as we have lots and lots of ones here. So you could see an exam question being like, what's the advantage of using conversational agents? Well, you can just choose one and start making something right away. So if we do Movie Expert and import that agent and just create it, let's give it a moment there to create. We'll peek around, but I'm going to tell you it's so complex that there's not much I can say about it, but we'll just go ahead and make it anyway. It failed to create it, wouldn't let me make it, so I guess we'll go back and look at the one that was made prior. I'm not sure why it wouldn't let us do it, but as you can see, you click into here, that has flows, you can click into there, and configuring this stuff is really, really, really complicated. There's probably a way that we could like test this. Again, it's been a while. This is not a new product. This product's been around for a very, very long time. So we turn on the simulator and we say where we want to start. So just saying, I need help with my order, please. Okay. And so here we can see in the default flow, it determined that the intent is check order status initiate, right? And then here we can see, is the operation complete? Check the status, is returning. And so then it's flowed over to here. So then it comes back with, I can help you with that. What number is your tracking order? So I'll say B432 second, whatever it is. And here it says page main menu. Here's the number. I'm looking that up right now. The current order is being processed. You should get an email tracking number when it ships. Anything else for you today? And so if we click into through here, we can try to figure out how it did this. So we go to the start page here. So that's the problem, is like, it can be hard to fall through this. So here we're on the default flow. How did it know how to get there? We'll go back here. Because this is the default flow, right? And I know it went to main menu. Okay. So anyway, my point is that it's a very complex system. If you learn it, it can be very useful. Again, this is not new technology. You don't need to know how to build this for the exam. You just need to understand that this is what it does, and it has predefined templates, okay? Let's take a look here at conversational insights. So this analyzes conversational data across the customer journey to provide contact center leaders and managers with data-driven insights to boost operational efficiency, improve customer service performance, and create better customer experiences. If we want to summarize that, it's AI-generated dashboards, or a dashboard, I should say, and reports on customer support team performance. So here you can see we have a bunch of agents, and we can see their quality score, how they're trending, if they're doing better or worse, some key metrics like business compliance, customer, and a CSAT score. Do they have a sentiment, like do people like how they're performing? So if that information, then under customer conversational history, we can see that we can go in and find a very specific conversation that occurred based on what the topic was or things like that. And in our dashboard, we have like different kinds of scores or metrics And that's basically it. So if you just remember it's a dashboard and like basically performance reviews and conversation history, then you know what conversational insights is, okay? Google Cloud Contact as a Service is an omni-channel contact center solution previously known as Contact Center AI platform. What's interesting is that at least today in the UI, it's still saying Contact Center AI, so I'm not sure why they have not updated the UI since this has been around for quite a long time, and the names change has been for quite a long time, so just make sure that you know that. I'd love to show you what this looks like, but it's an enterprise service, and so you have to contact Google. You can't just press a button and spin it up. You have to contact them in order to utilize it. But let's talk about its feature set. So it has intelligent customer experience across all channels and devices. We have multimodal omni-channel CX. So customer experience, so voice, chat, SMS, email, social, web, mobile, SDK, embedded voices, digital suite, and full customer journeys in the apps. Voice and web co-browsing for real-time customer support, AI-driven routing, predictive operations, and visual IVR self-service, automation of routine tasks and streamlined workflows, workforce and quality management, inbound and outbound voice, SMS with chat channel pivoting, agent productivity tools, insights, automated responses, preserved context. The way I think this is probably is it's an IVR with AI attached to it that also integrates with your CMR and has a portal. So that's what I think this is. But just understand this is a very comprehensive thing to adopt for a call center, and there you go. Okay. Let's take a look here at Google Agentspace. It provides a single secure platform to build, manage, and adopt AI agents at scale and unlock the potential of individual teams and entire enterprises. I think the simplest way to think of this is imagine ChatGPT, but like the same interface that you pay for, but it's shared with your team. So you can create agents and share agents among them. And I guess the idea is that information is supposed to be isolated for your enterprise. So that's the way I would think of it. Let's talk about its feature set. So you can create custom agents with Google Agentspace no-code agent designer. It supports the A2A protocol, the agent-to-agent protocol that Google has created. And it has pre-built connectors, so you can easily connect data sources into your knowledge base. And yes, I see the E is missing. I'm notorious for those spelling mistakes. And it has user access controls, agent provisioning, and multi-agent coordination. One thing it has is an agent gallery, so you can see some pre-made ones from Google, or if you make your own. I said from partners because, again, I didn't pay for this. It's an enterprise solution, and you got to pay $25 per seat, and you got to contact them. And so I saw this, and I thought maybe that means other partners. So maybe it's just Google, and this is the actual company that's there. And so either or, the point is that there's an agent gallery, and when your company creates them, creates agents, they put them into this gallery, and you can all share them together. This is that agent designer. So the idea is you put your name, your goal, the triggers, instructions. This is no different than, again, making GPTs in ChatGPT. It's just a way of creating those. And they obviously have some agent templates you can work from. They keep saying it's multi-agent, which makes me think that it can support multiple workflows without paying for this and calling them and saying I'm an enterprise and letting them use this. I can't be 100% certain, but for the actual exam, Google Agentspace is clearly just like a ChatGPT for your enterprise. And if you remember that, that's all you need to know, okay? Notebook LLM is a research and note-taking online tool developed by Google Labs that uses artificial intelligence, specifically Google Gemini, to assist users in interacting with documents. This thing is super, super fun and useful. I wish I used it more, but let's just talk about what it can do. So the idea is that you can upload a bunch of files or reference files from your Google Drive, such as PDF, document, slideshow. You can also reference YouTube videos, probably audio clips as well. And then the idea is that now that it sits in your knowledge base or your sources, you can then extract out information in various ways by asking it questions, or they have these predefined templates, like they can generate an AI-generated podcast, which is really good, make a mind map for you, generate out reports, but specifically suggest reports based on your topic, make flashcards, quizzes, and a little bit more. I think you can do video as well, but I've never gotten that to work. But yeah, give it a try. I show you what it looks like, and it's pretty straightforward, okay? All right, in this video, I want to show you Notebook LM, which still is a free service, I believe. Let's go over to it. So here we'll go ahead and try Notebook LM. And you'll notice here that I actually have some examples of notebooks. But let's go ahead and create a new one. And so the idea is that we can, look, it says experiencing issues that may affect the quality of your experience. Follow the Google Workspace status update. So there might be an issue with this right now, but I'm not super worried about it. Apparently we can upload like Google Slides. So it might be interesting for me to drop in slides into here, but notice we can take docs, slides, websites, YouTube links. So I'm just trying to think here, something that I could drop in here. Give me a moment. I'm just going to go get a PowerPoint presentation downloaded. 1 second. So I ran a boot camp a while ago. This is actually a few years ago, which was the AWS Cloud Project Bootcamp. And we had multiple documents in here. And so all I've done is I've just uploaded them. You didn't see it off screen, but you simply add it. And the idea is now I can ask any kind of questions I want. So maybe we go here and I just say, so what is the AWS Cloud Project Bootcamp? In summary, we'll go ahead and ask it that. And I'm just going to ignore the fact that it's under construction here. As long as it does some kind of output, we should be fine. All right, look, took a little bit of time, but it generated out. It says it was generated here. It was a 12-week program, et cetera, et cetera. So we get some nice, fun summaries. If we want to save that note, we can save it if we'd like it. Let's try out mind map. I don't remember this being a feature before, so it might be fun to see the mind map appear here. And it is generating down below. While we're here, we might as well make flashcards. Let's make an audio overview, which I think it used to be like a podcast. It is a podcast. So that might be fun here. And I'm not going to do a quiz, but we'll give it a moment here. This actually could be really good for study practice now that I'm looking at it here, but we'll give it a moment, okay? All right, so some of these have been generated. Let's go take a look at our mind map and see what we get. So here it's generated a mind map. So maybe we look at grading, and then it's breaking it down based on I guess it's just like FAQs about grading, because there was an FAQ in here. So they're like, okay, well, if we have grading and if I want to receive a grade and, must be an official student, then it brings me to that relevant piece of information, I think. Let's go try this here. Not really, but it's cool that it made a mind map. I guess it's just going to depend on what use cases. Let's go to flashcards. What is the primary goal of the AWS Cloud Project Bootcamp? To teach AWS. To equip individuals with skills to build, design, implement cloud projects through hands-on experience. Sure. This cloud project is a free, I think it was 12 weeks. Oops, 12 weeks. Yep, I got it. Who's the target audience for them? Beginners to advanced? Associate level, apparently. I like how I made this bootcamp, and I can't remember the stuff. What is the format of this cloud project bootcamp? Project-based? Instructions, Zoom, okay. So, it's okay. Like, you can see it made 67 cards. So this could work maybe better if you had more focused documents, but at least we can see what it's doing here. This will take a bit of time, but I do have a few other examples. So like imagine you want to look at bylaws. So I live in the town of Scriber, and I uploaded all the bylaws from 2024. And so if I have any questions about bylaws, I can ask them something. So maybe it's like, what is the budget for Scriber? So I might have said like, what is the Scriber Township budget? And then it pulled it out and gave me a breakdown of the budget of the town. So I had an idea. So that's kind of useful. I might have asked for a specific summary of bylaws. Yeah, so here's a detailed briefing document summarizing the key themes and information provided by the township. So I might go here and say like, what bylaw was the most notable? Right? I'm not sure if it can work with that, but we'll see what happens. We'll give it a moment. Clearly, it's a bit slower today. It's obviously still working, but we'll give it a moment, okay? All right, so it says the most notable can be subjective, but the most notable might have been adopts estimates for sum required for municipality operations during 2024, waste management bylaw. Actually, that was a big deal. They changed the way that we collect. This is from 2024, and we're totally in a different year now, but that's when they implemented garbage tags, and that made the town really, really mad. But yeah, those are good examples. I also think in here, we had an audio listening here. Let's see if we can get that audio.
So we're back for another deep dive, and today we're going all the way to Schreiber, Ontario.
Oh, well.
a town of just over 1,000 people,
Okay.
to take a look at their recently passed bylaws.
Interesting.
We've got a whole stack of them here, covering everything from taxes and staffing to some pretty specific rules about waste management and even fireworks.
Wow.
So you can see that it can generate out a podcast that sounds really, really good. Let's go back over to the AWS Cloud Project Bootcamp. And yeah, I guess that's going to take some time to generate out. But basically, the idea is that you can upload a bunch of documents and get the ability to ask questions and a bunch of different kinds of functionalities here. I'm not sure what the video overview would be. I've never generated one out before. That didn't exist before. And I mean, obviously we have different reports. I wonder if the reports are different based on what you're doing. So if we go back over to this one here. Yeah, it's slightly different. So it looks like the reports are adjusted based on the context of what you're doing. But that might be something you might want to try out. But you can see it's a very robust tool, okay? All right, so there's Gemini for Google Workspaces, and basically that just means that Gemini is now included. Whether you want it or not, it's included with Google Workspace. So you can see down below, Gemini, the little Gemini logo. But let's go take a look at what plans have what. So in the starter one, you get Gemini AI Assistant in Gmail, chat with AI in the Gemini app. You get Google Vids AI-powered video creator and editor. I didn't know we got that, so that's pretty cool. For Standard and Plus, you get Gemini AI Assistant in Gmail, Docs, Meetup, and more. So they're expanding just besides the Gmail and giving you everywhere else. You also get Notebook LLM with expanded access to features. I thought there was a free tier, but maybe I'm paying for Standard, and that's why I'm able to access it. Chat with AI in the Gemini app with expanded access to models and features. We have Enterprise Plus. And by the way, this is for Standard and Plus up here because I noticed there was not a huge difference between those two. For Enterprise Plus, you're going to get AI classification for Google Drive. Just assume that as you go up, it's going to include everything, and there'll be more of it as you go down. Also, Enterprise has assured controls and AI classification available add-ons. Do you need to know all of these for the exam? No, you just need to know that Gemini is within Google Workspaces and what Google Workspaces is. Let's take a look at this comparison about the Gemini app and see if there's any additional information here. So for enterprise-grade security and privacy, it's across the board. For access to Gemini app on web and mobile, it's across the board. Google's most capable AI models for complex tasks, and I guess you get the dumb models for basic. Build AI experts on any topic with gems. So apparently that's across the board as well. And yeah, there you go. Just know that Google Workspace has Gemini integrated into it now, okay? Let's take a look here at Google Gemini Gems. These are agents you can define within Google Gemini. This is the same feature as ChatGPT GPTs. You can explore gems. So here's one that already exists called the Chess Champ, and it's designed for us to have I guess, conversations about chess. They're not really hard to make. All you have to do is give it a name, give it a prompt, which is the instructions, upload additional documents, and there you go. All right, so I'm in my Gmail. Obviously, don't want to show you all my emails. That's why I have it like just kind of pulled here on the side. So you'll have this button, you'll press it here, and then you'll have options like what can Gmail do? Delete messages prior to a date. Sales pitch ideas. And so I think one interesting thing are the gems. Like here, you just talk to it, right? So you say, what can it do? And here it'll tell you what you could do. So you could summarize email, draft email, suggest responses, search for emails, things like that. And so you just say, how many more classes do I have scheduled for Japanese lessons with my Japanese teacher? Because that is something that I have here. And let's see if it shows it. And it doesn't know, but it's definitely in my email. So at one point when I asked it, it kind of knew my teacher's name. So let's try it here, but we'll clear out the history so we get back to the main menu. But the idea is that it supposedly can search across it, but really depends. There are gems here. So we could say, if there's more, let's take a look here. Sure, we'll do this one. This is probably what's driving all that spam these days. Yeah, we'll do write an apology letter. There we go. And so here's a template. I don't know if that's really any use. Let's clear the history. Let's see if we can go ahead and create a gem. So we saw gems there a moment ago. 1 second. Let me see if I can back out. I just clicked the back button there. Sometimes this actually closes the entire box. I'm, again, just not trying to show my emails. Let's go ahead and create a gem. And so it's asking me to open a Gemini in a new tab. And so here is our, as you can see, I do a lot of Japanese vocab, right? Okay, and so we'll go, got it, and we'll create a new gem. So the gem will be, I don't know, Japanese language quiz. Give me quiz questions for JLPT N5. And I'll answer them. So this is exactly just like ChatGPT, GPTs and stuff like that. You could add files for reference. We'll go ahead and save that. Start the chat, sure. And we'll just say, let's go. Right now we're just using Flash. Flash is not the best for Japanese language, but here we have an example of one. And there you go. So you just learned what gems are, and you learned that it's in there, the Gemini stuff. I'm not going to show you in Google Docs and stuff like that. You get the idea, but there you go, okay? All right, let's take a look here at Google Vids. This is assuming that I'm able to utilize it. I actually do have a workplace business account, so in theory, I should be able to use this. So we'll go find out here. All right, so I am in here. And we have some options. We got VO3 to generate 8-second AI clip. We can do some storyboarding. We have AI avatars. I don't know why we record ourselves, but I guess to inlay with some kind of stuff. But I guess the most interesting thing is probably using VO3. At one point, this is only available in the US, and so I guess now I can use it in Canada. So generate 8-second clips, custom video clips. And that's the only option we have. So I'm just trying to think of something I might want to generate. So, you know, the type of dog I have is called a dachshund. So we'll go here, dachshund, and we'll say, generate a 8-second video of a brown and tan dachshund that is cooking or that is eating a blueberry pie. So that's kind of an unusual one there. We'll go ahead and hit create, and we'll wait for our video to generate, okay? All right, so our image is generate. Oh, sorry, I didn't realize there was a lot of audio there, but we have audio. It was a lot louder than I thought. I don't know if you can hear it, but the dog's eating. That's really, really impressive. But yeah, there we go. I mean, there's obviously other things that you can do in here. I'm not really sure if any of that is really that necessary to look at. I'm sure we still have our image here. Oh, where'd our video go? There it is. But yeah, I guess you can insert it in here. Yeah, I guess we can do other things with it, but I'm not really interested in changing it in any way. I think that's fine, but there you go. There's Google Vids, okay? All right, in this video, we're going to look at Vertex AI Studio. So we'll go over the Vertex AI page and go to Vertex AI Studio. Here we have multiple options to generate stuff. Vertex AI Studio is just an easier way to work with the various types of models that are available on Google. Every provider has basically built one of these easier to use interfaces for those that are not super technical. But let's go ahead to new and look at chat first. So here, we have our chat, and down below we have our prompt where we can start writing things. So let's take a start here and set up a scenario. So normally when you are writing your prompt document, you want to provide a role to the LLM so it knows exactly what you want. And so down below here, we do have a prompt, and we could start writing here the role, but if you look on the right-hand side, we have system instructions. And so that's where we're going to bring in our system information. So I'm going to say role. As you know, I'm learning Japanese, so that's how I'm going to make it. So I'm going to say Japanese instructor. Now, some folks might be more detailed in their information in terms of what they define. I personally just like putting role and then scoping it in particular. So I might say like have role and then requirements, teach in English, teach in English. That'll definitely be something we want. Scope, we'll say JLPT N5, right? That is the scope of Japanese certification, which is the entry-level certification. And then we could say like tone and just say friendly but concise, okay? So we've now set up our system instructions, and we can go ahead and start prompting it. So here I'm going to write something out. So we can say, let's practice common verbs, okay? And so we'll hit enter here. I'm not sure what the mini map is for yet, but it says great idea. Practicing common verbs is super important. I guess as we work through this, we'll see. The reason I'm confused is that other providers don't have a mini map. So this is new to me as I've used Vertex AI Studio, but this is the new version. So I'm not exactly sure what's going on here. But great idea. Practicing common verbs is super important. N5, let's dive in. So here it's talking about taberu, and it's asking if we know what it is, which is easy. Notice up here we have different options for our model. So we're using 2.5 Flash Lite. Different models are good at different things. To be honest, Google's not good at Japanese at these lower levels, so I'd probably go with Pro. And here we will go ahead and try this again. So I'm going to copy this. And I wonder if there's a way that we can clear out our conversation. I don't see an option here. The only frustrating part is that I might have to copy and paste this multiple times. So I can just copy this here and I guess click new chat. You're about to exit. Your changes will be described. Would you like to continue? Well, I don't see any option to save. So I'm not exactly sure what it wants us to do here to carry it over. But that's okay. So we'll copy this and we'll just make a new chat. We'll say continue. And so now this time I'm on Pro. And we'll say, let's practice common verbs. Okay. And notice that this model is a little bit different. It's actually thinking through what it's doing, whereas the other model was a bit single response. So when you see a model that's thinking, what it's doing is it's actually calling itself multiple times. And it's also using chain of thought reasoning to think of a good response. So this one's actually a lot better than the other one. The other one was okay, but this one's thought about. So let's take a look at how it thought. So it says, focusing, I'm concentrating on the JLPTN5 verb for verb selection. It's vital to keep the scope narrow by prioritizing the most common verbs at that level. I'm structuring the verb presentation now. My goal is a clear, digestible list format. I've now refined the structure and added example verbs. I'm now focusing on responses, and I've selected a core set of N5 verbs. I've now refining the prompt, designing the interaction. So here we see 1, 2, 3, 4, 5, 6. And so underneath, it could be making 6 calls to get to this end result. And so you have a much better refinement. Now, you as the prompter, you could work through each of these and like talk to it 6 times to get to it. But this idea here is just to help it reason and get to the result that you want. So we go down below and we have 5 or 10 verbs here, 8 verbs. And then we have a little bit of practice, and then it asks me to do practice. So I'd say that is pretty good. We have a lot of other models here as well, but Pro is obviously going to be the best here. If we go to a third party, we have Claude Sonnet, DeepSeek, which was popular at one given time, Meta, which is a very popular open source one. And if you had tuned libraries, you'd have that in there as well. I do remember being able to see here to do grounding, and so I'm not sure why we don't see it here. It could be that we're using the newer interface, as the old interface had tuning here on the right-hand side. Oh, here's the save button. Okay, so maybe we can save it here. So Japanese tutor, Japanese N5 tutor. We'll go ahead and hit save. And so if we go over to code here, there's our code example. We wanted to implement it, but what I'm trying to find here, here, more settings. Okay, so we have our model here. We'll expand it. And here we have thinking budget, so auto or manual. The model only thinks when it needs to. So notice when we used Gemini Lite, it wasn't thinking. It just, like, it did produce an output, but this one iterated through it, which obviously would use more stuff. We also have structured output here, so we can say give us back something like JSON. So input instructs the model to output a specific format. So if we click on this, and here we could tell to give us a very specific format. So I can go here and say, like, I'm writing JSON to get the structure here. So I might say lesson, describe the lesson, vocabulary. We'll say example sentences. And then here, I'll go here and say Japanese, English, okay, and so here I have a bit of something. I'm not sure if that will work. We'll go ahead and hit apply. So it has an issue somewhere here. I'm not exactly sure what, but I'm just going to go simplify this so I can see my structure a little bit better. You know what, it's missing this one right here. There we go. Apply. There's still something wrong. So we can take a look at the structured output here for a second. And I'm just looking for an example. Let's go back over to here for a second. I'm going to pause here and see if I can find the structure. I think it's expecting like this kind of schema, which is, I forget what it's called, but maybe it's like schema JSON or whatever. So I'm going to go over to here and copy this. And we'll go to Gemini AI Studio. And we'll just go here to this one, the second one maybe, as long as we get in here. So I'm going to go, and we're on Pro right now. So I'm just going to go paste this in here and say, turn this into the schema that Google Gemini Pro needs to format out JSON. Maybe it's schema JSON. Okay, which is a thing. I think that's what it's called. And let's see if we get that structure here. So it's thinking. Okay. Obviously, the Google AI Studio is very, very similar. The UI is a little bit different. I mean, Vertex is, I would say, simpler. And so here, this looks like the schema format. Yeah, so I'm going to go ahead and copy this. We'll go back over to here, right? And then we'll hit apply. And that worked. So that's like schema JSON, maybe. Here it is, JSON schema. And so I believe that this is what it's coming from. Right? So if we go to this, I'm pretty sure it's based off of this. Okay. Yeah, it looks like this. Okay, so that's probably what it is. They changed the website on me, as per usual. But if we go back over to here, so now we have very specific structured JSON output that we want, which is here. So give me the next 10. Okay, so I'm going to hit enter here. I really want to restart the conversation here. Give me the, something weird's going on here. And so I'm going to just hit the save again here. Save. And so I'm hoping that it's going to save this output. I just don't know if when I make those changes, if it's going to remain. We'll give it a moment to save. So here I just got a message. Saving is taking longer than usual. This is expected when saving the first prompt in a region. Please allow extra time for processing. That's bizarre, but I guess we'll just wait a little bit longer, okay? That took a very long time to save, but we're going to go ahead and make a new chat because we're having some issues there. And notice that the cloud here, we can, oh, it's over here on the left-hand side. So we'll click here on our left-hand side. But I want to restart the conversation. It doesn't make that easy for us. Okay, so I'm not sure why. I can't find it here, but that's okay. We'll go ahead and we'll just go. So, okay, give me the next 5. And I want to go here and make sure my structured output is in here still. So it is still here. Let's go ahead and hit enter. And so I want to see if we'll get JSON back. Okay. So we'll give it a moment here. And there we go. We're getting structured output, and it's perfect structured output. So that's really, really nice. At one point, and structured output is a very difficult challenge with the LLMs, but there's a variety of them that don't have this option. And so the fact that this is built in right into here makes it really, really easy, really, really nice. So we do have that. We could also do grounding. So I mean, this is all fine. I don't feel like our use case is too complicated, but we'll go ahead and turn on grounding here. Does not support the selected text format. To use grounding, select plain text as the text format. And this is because we have structured output, so I'm going to turn that off. If I go back here, is it still there? Yes. So if we turn that off, then we can turn structured output on. Grounding with the Google anchors outputs to verifiable information. So we have Google Search and Google Maps. We'll go ahead and hit Google Search. So the idea is like, what would we need to verify against the internet? So I might say like, okay, what are the grammar points for N5 that boonpro.com wants you to learn? So there's a website called Boonpro. We'll go over to here for a second. Boonpro.jp, yeah. And so it wants you to learn very specific ones. So we're going to see if it'll actually go and ground that information out. We'll give it a moment here. All right, so let's take a look here. So here, of course, based on the official curriculum, Boonpro JP organizes N5 grammar points into 10 distinct lessons. So here are the 10 that it says that it has. Let's go see if that's actually true. So I'm going to go to my grammar list over here. Again, I'm just comparing something I know. So things that are crucial to make interesting sentences. Yes. So yeah, there, it looks like it's doing what it's saying it's doing. If we go back over to here, this path will take you through essential particles like ni, de, o, kara. That's correct. It's showing the citation sources. It's showing grounded sources. So I'm not sure why it went to Koto Academy or JPTL Samurai. I'm not that familiar with these ones. Yeah, it's fine, I guess. But it really doesn't need to go anywhere but Boonpro, but that's totally fine. And we can see that it's grounded. So that's pretty cool. Let's scroll down here. Some other things that we have is like temperature. So if you want, yeah, it's a higher probability means, okay, so lower temperature is good when you expect a true correct answer. A temperature of 0 means the highest possibility token is usually selected. A higher temperature can lead to diverse or unexpected outcomes. Okay, so the higher the number, the crazier the thing. So if this is not creative enough, we could just cram this all the way to the top. Here we can determine if we want to have less information. So imagine we want something really concise. So we have 65,000. Let's go down to whatever. And also the reason why you might want to reduce this is going to save you money because you're using a larger thing here. We can also set our seed. So we have, I think, more of a deterministic behavior, but we'll leave that alone. We have our top P. And I usually don't fiddle with top P, but I know it has another effect on the creativity of the output. So we'll leave that alone here. Stream model responses that are generated, so we can send them somewhere else. Let's take a look here. Nope, that's a stop sequence. So I guess we can't stream this one other places, which is fine. And, okay, so minimap is basically just a summary because this is so long to scroll, and I guess maybe we can click here and jump to it. Okay, that's not bad. But now that we have that information, let's go ahead. Like, we've changed it to be really random. So, like, okay, so how does Tai Kim break down grammar for N5? So go ahead and ask that there. He doesn't actually do an N5 grammar breakdown. He just has a general guide on it. But we'll see what it does, and we'll see if this feels wildly more creative. Okay, so we'll give it a moment there to finish generating. So it is done. It didn't go out to the internet. I'm not sure why it didn't. I guess it didn't need to ground it. Okay, can you check the latest version on his website? Okay, because it didn't go out to the internet, right? We'll give it a moment here. And see, now that I asked it, it's explicitly providing references here. Okay. And so here we have a bunch of references. It's going beyond just, I don't think any of these are his website. Maybe Guide to Japanese's? I don't think so. We'll go over to here. No, but this is a good website as well. But the point is that it's kind of not going to that source. So we might have to tell explicitly what source we want it to go to. In terms of creativity, I could barely notice any difference. But you have to check these on the most extreme to find out. But I would say that is a solid example. If you wanted to use the code, here is the code. You could switch the language. We don't have Ruby, but we have Python, I guess. Looks like we could also deploy this to Cloud Run, which is really nice. I assume we just take this exact code and deploy it there. You could also bring it into a notebook, which is really nice. I'm not sure why we have all this text here. So I would say I do not like the output of this code, but at least you have an example to work with, because you wouldn't want all of this in here, right? So this is a bad code example. I would definitely not use it. Looks like we have version history, so maybe it would show us the changes we did to our prompt. Yeah, so we can see things that we did that are different. We could restore a previous version. None of this will show up on the exam, but it's things that you probably want to know. Down below, we have tools. There's only 2 tools here. I'm not sure. Maybe there's a way to define more tools to attach here. Some of these models can generate images, but this one in particular. Oh, I guess you could upload referenced files and stuff here. So this model can take other inputs other than text and analyze it, but I'm not going to worry about it there. So that, I guess, is an introduction to the chat. We'll continue on and look at these other ones, okay? All right, we are back and we're continuing on learning about the different options of Vertex AI Studio. So we're going to drop down and go to images. And so here we can generate out our own image. It looks like we also have the other options here, which is probably just an easier way to get to those there on the left-hand side. But let's go ahead and take a look. So we have a bunch of different imaging models. We'll just stick with the standard 4. We have different aspect ratios, the number of images we want, so we can select what we want. The resolution, 1024 is fine by me. We can set whether we want this to be safe or not safe. Obviously, there's going to be some degrees to what we'll block. And we'll just put it on high because, I'm recording a video. I just want to make sure everything is safe here, what I'm generating out. But generally, these have very strong safeguards, so you don't get anything too crazy. But we'll go ahead and say generate an image of a I can't ever spell dachshund. Dachshund. That's the type of dog that I have. So dachshund. A short-haired brown and tan dachshund eating a blueberry pie. So we'll go ahead and we will do that. And we're going to get 4 options here. So we'll give it a moment to generate. There we go. We have it. These are okay. They're not like the most super realistic. We do have some other options here, like add elements and do in-painting. So we could go here and we'll take our brush here and I'll just select what I want to change here. Right. And we'll just say, change the pie to cake. Let's see if it'll do that. So I'm thinking with that in-painting, where I selected it, it would know what I want. So I have insert, remove, outpaint, mask-free, product background. So a lot of options here to change it. Notice that it's using a different model. It's using image in 3 capacity. And I would not describe that as a cake. I would describe that still as a pie, but it was nice that it tried. So whatever. But let's go back to our history here, and we'll go back to our one that's here. I like that one. And we might use that to generate a video next, but there's not much to say. Like, it's pretty straightforward what we did there. So we generated an image, okay? We are back, and we do have this image here, but let's go ahead over to video and generate a new video. This is using VO3, so I'm pretty sure these are the same or similar models that Google Vids is using. And so my expectation would be something similar along that lines. So we're going to go with a short-haired, shared brown and tan dachshund. Again, I can't spell the word dachshund. Dachshund. There we go. Eating a blueberry pie. But it seemed like in our last one where we had an image, we could take a base image and convert it to a video, which is fine, but we'll give this a moment to generate out these videos, okay? That was pretty fast. Let's take a look. So we got our first one. And notice we're getting, well, you probably don't hear it, but we actually have audio with it. I'll turn it down a bit. Okay, we'll go over here. Looks just like my dog, but my dog's a bit fatter. Works pretty well, surprisingly. I'll just turn off the system sound there. But yeah, you can see we have 864, so 8 seconds, just like the other one. Obviously, there was more options in Google Vids in terms of how we could edit it. So it wasn't just about generating it out, but also having an editor in place. Obviously there's safety options here. We could have added a reference or a style. I suppose we could still do that. I'm not sure how well that would work. I've just been watching the show Gurren Lagann, so maybe I can find an image there and upload it. Just give me a second. If we want to add a reference, we apparently have to use VO2, so that's totally fine. We'll go to that preview. And so I've added a reference image here. This is the one that I've added here. I'm not sure if it can really do this, but we'll give it a try anyway. And we'll go ahead and hit enter again. We'll see if it picks up that style okay. Well, it picked up that it's a cartoon. I definitely wouldn't call it in this particular style, but hey, it gave it a try. Let's take a look. And in this case, I'm not getting any audio. Like, notice there is no audio option. Some of these are, just falls right out of its mouth. Okay. But hey, it gave it a try, so that's not too bad. So you have style, then there could have been the subject. So not a whole lot of options. Obviously, VO2 preview is not as nice as VO3. But yeah, I guess that is good, and we'll continue on, okay? All right, let's take a look here at music. So here it will generate out music for us. I'm not sure if it would have speech or not. So we have Lyria too. So we'll go ahead and say generate out a theme song for an upbeat, or we'll say for an anime based around a epic space opera. Okay, let's see if it can go ahead and do that. That's pretty crazy prompt for it, but we'll give it a moment and then we will listen to the output, okay? All right, let's take a look at what we have. We apparently have 3 samples, so let's hear the first one. I'm gonna just turn my system sound on so you can hear it, and we'll turn it to half. Okay, that's something. Sounds like the same thing. Literally sounds the same. So let's go take a look at what this Lyrica can do. Lyrica, because it's only sounding like, I think because we're doing all the anime there, I thought I was trying to search a show, but we'll say Lyrica to vocals. Can it do vocals? That's what I'm wondering here. Google. It's really giving me some weird stuff. Okay, let's look at the showcase then.
This energy is pulling so bright.
Okay, so maybe what we'll do here is go back and give it a little bit of help. If we go back over to here, and we'll hit reset because that wasn't the best. And so here it says an energetic, dreamlike bouquet filled with a dubstep beat. So it wasn't really descriptive of like what a show is. It has to describe what it is. So I'm going to go back over to, we're getting a little bit of help from chat here. So we'll go back to chat for just a second. And yeah, we'll just say, I need a prompt for generating music, specifically for a Japanese anime show, like a space opera, maybe similar to Legends of the Galactic Heroes. Can you make me a prompt that describes that? Let's see what we get. We're on Flashlight. I'm gonna go to Pro. We'll probably get a better results with Pro. And actually that kind of works. This actually would probably work. So I'm going to go ahead here because that's kind of descriptive of what that other show is. And so we'll go back over to music. And here, I don't know if it'll really take those things into account because it probably doesn't understand that, but we'll go ahead and give it a try anyway. Because it seems like the language that Lyria 2 is using is very like, don't tell me like, it's like a show. Tell me that, like how you want it to sound. But we can go back over to, oh, this is another tab here. We'll just go over to here for a second and give it a moment to load. We'll go back over to our chat and we'll go to here. Okay, but the prompt can't have, okay, but just describe the music. You can't reference the show. Let's see if it takes that there. I don't know why that happens, so we'll give this a nice hard refresh here and see if that fixes the issue here. But sometimes I can't write in here for whatever reason. Here we go. So we're on Pro. So, okay, but we need, okay, so give me a single prompt. And remember, and the generator is not going to understand anything other than musical descriptions. So referencing the show or what its theme is not going to help. Okay, so we'll go ahead and now we have Pro helping us out here. While that's going, let's go back over here and see what we got. That kind of like is like the show. I'd love to play the real music, but I don't want this to get flagged on YouTube if we put this on YouTube. Let's go to that one. Having two never really helps because I can't ever notice the difference. We do have a two over here. I'm not sure why they do it like that. Okay, cool. So go back over to here. So what do we have here? The composition must feature wide, powerful moments. Okay, so we'll go ahead and try this new prompt, which looks a little bit better. I'm not sure if we'll get better results. We'll go ahead and we'll put this one in. We'll give it a second to generate. All right, let's see what we have. Not bad. But it's really generic, obviously, so. But it's nice that you can generate it out, but I'm not sure exactly what you'd have to do to work the prompt to get something more dramatic. But anyway, there you go. It's in better hands, they probably can make something better. But yeah, there are docs maybe describing exactly how you can prompt this, possibly. Yeah, I would have to spend a lot more time with this. Oh, so it even says basic writing prompts: general style, mood, emotion, instrument, tempo, rhythm, arrangement, structure. Okay, well, let's go back over to here. Let's go back and just try this one more time. And okay, can we make, I'm going to say the generated music is fine, but it's boring. Can we provide it more description of the structure? Okay, and so now we've basically given it the actual structure of the prompt, so we'll give it a moment here. So here it's exactly following. Oh, cool, this is what I wanted. So we have sections here. I didn't know if we get that or not. That is really cool. So we'll go ahead and we'll copy this. And it is pretty detailed here, but we'll go ahead and give it a go. And too long. Okay, so we'll go back over to here. So we'll now give it that. So there's one issue that we have. We'll give it just 1 second here. All right, so here we have a shorter prompt generated. And hopefully this one fits. Okay, there we go. We'll see what the output is. We'll give it a moment. Looking forward to something good. All right, so now I'm curious, is it going to take into account going back over to here? So we have start quietly with a melodic solo piano. Nice. At 45 seconds. Well, is this thing's only 32 seconds long. So maybe something we need to do is adjust this. This doesn't work. So the problem is the audio can only be about 32 seconds. So we won't hear most of the structure. You need to rework the structure. Okay. So I guess I didn't think of that, but let's hear it anyway for fun. Is that a piano? Start with a solo piano. Uh-huh. Yeah, none of that sounds like a piano. But anyway, we'll give it the benefit of the doubt and let it try one more time here. So here we have a new one. Okay, and let's go ahead. What if we could just take this part here? Okay, and I'm gonna make new music. Just new music here. Just reset so I don't have to see any of this. Let's try this, okay? So we're just taking the structure. It has a lot of information in there. Let's see if it can do it, okay? All right, so moment of truth. Well, I mean, it definitely did one part of it. Let's continue on. Well, anyway, you can see that there's a lack of ability for it to transition and do other things, but at the very least, that is really cool, unless I'm prompting it wrong, but there you go, okay? All right, let's take a look at Vertex AI Studio New Speech, which is just going to let us synthesize voices. So here we only have one model option. We apparently cannot change anything else. I'm not sure as to why. I guess we have to enable it first. Oh, it's just using text-to-speech. So there's a text-to-speech service within Google. Normally you'd interface or find it another way. So if I go to Vertex AI over here, and we go to the left-hand side, normally they would have text-to-speech somewhere here, but maybe they've moved it into here. But the one thing that I never liked about text-to-speech Cloud before was just it was always kind of a pain to use because it didn't have, I guess they've really moved it, but yeah, it didn't have an easy way to like change some of the options. So maybe this is a little bit nicer. I'm going to go over to Japanese. Even if you don't understand it, that's totally fine, but I just want to go to Japanese. And we have a bunch of different voices. We'll choose the first one. And we want to have some text. So I'm going to switch over to my Japanese keyboard. And we'll give this a go. So we'll say Nihon, Nihon, or we'll say konnichiwa, konnichiwa, ohayo gozaimasu. And we'll say genki desu ka? Okay, so a very common phrase. Japanese. We'll go ahead and enter it in. We'll try English after this, but wow, that was fast.
こんにちは、おはようございます。元気ですか?
That's pretty good. Let's try another one.
こんにちは、おはようございます。元気ですか?
And another one for fun.
こんにちは、おはようございます。元気ですか?
Great. So now we'll go over to English. I mean, I'm Canada, but we'll take US, I guess, here. And I'm just getting back to my normal English keyboard. 1 second. Isn't it? Okay, we'll give that a try here. And, oh, you know, it's interesting. I guess the voices are normalized across languages. Okay.
Hello, how How's the weather? Nice today, isn't it?
That's pretty good.
Hello, how's the weather? Nice today, isn't it?
Hello, how's the weather? Nice today, isn't it? Hello, how's the weather? Nice today, isn't it?
And I'm just curious, if we go back to Japanese using English text, what will happen?
Hello. How's the weather? Nice today, isn't it?
Hello, how's the weather? Nice today, isn't it?
I'm just curious, like, if we can get some fun accents. So if we go over to German, let's see if we get a German accent.
Hello. How's the weather? Nice today, isn't it?
Kind of. Let's try Spanish.
Hello, how's the weather? Nice today, isn't it?
Kind of, yeah. So it's interesting. It's like you kind of get accents, not fully, but to some degree. I didn't know that we could get that there. Yeah, we just have chirp 3, so it's okay. There you go, okay? All right, we're back, and there's one more to try, which is live. And apparently I can talk to it live. It's picking up my microphone, so we'll allow this time. And we can share my screen. I don't really want to do that. Well, I'll just start a session. Hey, this is Andrew. How you doing? Oh,
Hey, Andrew. Hey, Andrew. I'm doing well. Thanks for asking. How can I help you today?
can you
I'm
teach me
here to assist with
Japanese?
any- Sure, I can help with that. What kind of magic trick would you like to learn? There are many different kinds.
Not magic, Japanese.
Ah, I understand. You like to learn some Japanese. What part of Japanese would you like to start learning? We can go over basic phrases, pronunciation, or anything else you're interested in.
Let's practice the Japanese grammar point teru. Teru.
Okay, let's practice the teiudu form in Japanese. It's used to indicate ongoing actions, states, or completed actions with lasting results. Can you try making a sentence with it?
Ikimasu teru.
That's a good start. The correct way to say is going using the teiru form with the verb ikimasu is itteiru. You change ikimasu to the te form, which is ite, and then add iru. So itteiru means is
Okay,
going.
so how about Nihon ni iteru?
That's almost right. You just need the particle ni to indicate the destination. So the correct phrase would be Nihon ni itteeru, which means is going to Japan.
But
or
that's
has
what I
gone-
said.
Apologies for the misunderstanding. You said Nihon ni itteeru, which was correct. It means is going to Japan or has gone to.
Cool. So we're getting kind of that functionality that we get over from ChatGPT. I would probably say ChatGPT is a bit better. But the problem with these is is what the model is restricted to. So it's using 2.5 Flash, and so I don't know. Like sometimes they work, sometimes they don't. I'm assuming this is an audio to audio. Yeah, it is audio to audio model. That means that it's not turning the audio then back to text, interpreting, and then going back to audio. It's literally interpreting the audio and outputting audio. Apparently, it can do video, audio to video as well. And it's okay. It's okay. But it's not going to be as good as the other ones. We do have some other voices here, but I don't care. And we can obviously do screen sharing and show them other stuff, but I'm not going to do that here today. Okay. Ciao, ciao. All right, so let's go take a look at Agent Garden. This is just a bunch of pre-built customized blueprints, and they're almost all using the ADK. In fact, I don't think I've seen one that's not using the Agent Development Kit, but there are some variant in languages. The personalized shopper is a very simple one. These are all repos on GitHub. And so if we scroll on down, we can see the architecture. So we have the personalized shopping agent, which can do tool call out to search and click. So if we go into the personalized shopping directory into the agent.py, here we can see that we're importing agents and we're importing tool use. And then we have two tools defined. And then here we're importing our prompt. We're using Gemini Flash 2.5. Here we provide the instructions, which is our system information. And then we define our tool. So function tool, function search. So we're mapping the function tool to the search here. Let's go back out, look at the prompt. So here is an example of our prompt where it's describing the interactive flow of how they want the conversation to go, which is fine. We will back out. We'll go into tools. We'll look at the click.py. And so, tools are basically functions you define, and then the LLM knows the exact parameters of how it has to pass them in here. So here we have the args defined, and it's just taking the the click and doing something with it. If we go back over to search, there's a few different ways that search can work, but let's see what they're utilizing here. And here they are searching. I thought maybe it'd be like Google search, but back to search, web shop environment, the string. So I'm not exactly sure how the search works here, but they are importing this web shot env over here, but those are just init variables here, init variables. So maybe here, maybe if we keep digging a little bit deeper, maybe we'd find the search engine. I mean, the search engine looks like it's static data, which is totally fine. But the takeaway here is that Agent Garden simply is things using the ADK, and it's just they're all linked on GitHub there, and it just helps you to start building your own agents. Okay, ciao ciao. Let's take a look here at the A2A protocol. So A2A, known as Agent to Agent, is an open protocol specifically made by Google that allows AI agents to securely communicate with each other. A2A is an open protocol that complements Anthropic's Model Context Protocol. So you often hear about MCP and A2A, and so folks think that they are competitors, whereas they can be used together and have different use cases. But A2A has over 50 technology partners that have given support and contributions to A2A. Hello, testing 1, 2, 3. Hello, 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 hello. Well, let us take a look here at A2A, also known as Agent-to-Agent Protocol, is an open protocol that allows AI agents to securely communicate with each other. Specifically, this protocol is made by Google, so that would be a reason why we would show this in the Google course. A2A is an open protocol that complements Anthropic's Model Context Protocol. So these two, a lot of people think are competitors. They're not. They do different things, where A2A is about agent-to-agent communication. Model Context Protocol is about external systems contacting a model, so it doesn't have the same level of sophistication about coordinating two agents communicating. But anyway, there's over 50 technology partners that have given support and contributions for A2A. Google wants you to know this because there's a lot of competing protocols, and they want to show that there's been great adoption here, and you should use A2A. You can use A2A, but we never know, what wins out in the end here. So, what can A2A do? Well, A2A allows you to create these agent cards in JSON format that sit on a domain name that can be discovered and let you know how to interact with another agent. Agents communicate over HTTPS using JSON RPC format. If agents support streaming, they can stream with SSE. You have to implement your own agent executor to understand incoming requests. So they do have a bit of a standard way of how they want data to be handled back and forth. I found it really confusing trying to make sense of A2A. I think it's better just to look at the code and be able to understand the structures behind it. That's what helped me understand MCP. So let's go take a look at a code example after this, okay? All right, so I'm over here at the A2A project repository. To be honest, for the Google certification, the Gen AI Leader, we just generally have to know what A2A is. If my slide wasn't enough, you could watch this video here. It's really good at breaking it down visually, so I do recommend it. But I do think it helps to look at a bit of code here to see how it works. So there is various SDKs that you can utilize. Again, it's an open protocol, so any SDK can be implemented. But let's go over to the Python SDK. As that's usually a popular choice. And if we scroll down here, there should be Python examples. And then from here, we have agents. And you can see that these agents, which are implementations of utilizing A2A, they're not like specifically the ones that they're providing here, examples like a very specific business use case, but these are wrapping around generic frameworks, which is kind of interesting. But I guess we can go into any of these. Okay, we go into here. And so if we go to the top for a moment to the actual line graph here, what I'm looking for is some of its structure. So if we go into app, Notice here we have the agent executor. So I told you that you need to implement an agent executor so that it normalizes the request. And notice in here that we are bringing in some information. So we have events, we have tasks, we have types. And so the idea of your agent executor, which you have to implement yourself, is that you are normalizing, you're basically creating the adapter so that both of you can communicate. Okay, if we go up to the agent level, there's nothing super exciting here. Like this is all land graph, so this is nothing to do with the what do you call it, the executor itself. Okay, but for the most part, most of the code is contained here. Now, where are the agent cards? I don't know. I would have to do a full implementation for us to figure that out, but I just wanted to show you generally that the way this framework is working is that it's basically standardizing communication by creating this adapter here, okay? There you go.